These pictures right here are not actually me. They are generative AI with my face in it. Now, this is not face swapping. These are quite literally taking inspiration from images that I gave it. I fine-tuned a model to be able to produce these two, but it produces so much more. So we can actually cycle through these. Some of these still really look like me. Some of them not so much. Some of them are just fantastical. They are just out of this world, not realistic at all. But the thing about this is this process is shockingly easy to do these days. So what we're going to do here is we're going to build out our own generative AI model. We're going to fine tune it using the Replicate API service. There's a lot of different ways on how we can fine tune models in here. Once we have a fine tuned model, we're going to turn it into our own micro API service. Now, the way we're going to do that is by using FastAPI. In other words, our application is going to be a proxy that calls the Replicate API. Now, the reason for that, of course, is because the generative AI stuff is moving incredibly fast. So Replicate is great today, but maybe you're going to want to use something different in the future. If that's the case, your microservice will be well prepared to be able to do that. Now, one of the biggest downsides of building out generative AI tools in your systems has to do with the fact that every time you generate something, it's going to have some cost implications. And those costs can get wildly out of control. So in addition to building out our FastAPI application, we are going to put rate limiting in at the very beginning, as soon as humanly possible, so that we aren't overloading our bills. And the way we're going to do that is with Upstash's Redis serverless database. There is so much you can do with Upstash for absolutely for free. Now, I partnered with them on this course to make it really easy for you to do all of this. So thanks to Upstash for that. But the idea here is, I think, very, very practical. I want to show you a demo in just a moment, but I just want to reiterate the fact that we are building a microservice with FastAPI that happens to integrate with a generative AI tool, which of course I'm going to show you techniques to get all of that working and working well so that you can deploy it wherever you want, whenever you want, and using any kinds of image generation. This just happens to be the data set I traded on. You can do it on your own images. You can do it on many, many others. So it's really, really cool, and it's a really awesome time to start working with generative AI. Let's take a look at the demo right now. For the demo, I created this specific notebook that we can run that allows us to add in our own prompt with a trigger word. So this talk here comes from Replicate. It is a trigger to make sure that we're using what we trained on, which is my images or yours if you end up doing that. But the idea here is after we have the prompt, we then call our own API, our own endpoints here to start generating a image or however many images we might want. Then I have a few different functions in here to wait for those images to finish and then download them after they have finished and then display them on my local machine. Now, so much of this is going through our own API. So learning how to build a microservice like this, I think, is going to get more and more important. So here's those images that were just generated. It is wild to me. That looks like it could be the back of my head. I can't even believe how close that is. This doesn't really look like me, but here's another one that sort of looks like me as well, at least my profile. It's wild how good this is. Now, the other thing about this, though, the actual practical part of this is anytime you need generative AI, you might as well wrap it into a microservice in this case. FastAPI is a really good use case for that. That is what it excels at. We don't need a SQL database at all. The only database we really need is going to be using a Redis data store so that we have that rate limiting, and Upstash has that serverless option. So we only pay for what we use anyway. So it makes a whole lot of sense. Now, when it comes to what we pay for, this entire course itself is a maximum value. If we look at our dashboard on Replicate, I did $4 worth of training the model one time and then doing all of these different inferences on here. So $4 to run all of this. Now you might imagine if you're running hundreds and hundreds of times, then yeah, it's going to be a lot more than that. I've only run it 34 times and I showed you some of the images in there. So making sure that you actually have some rate limiting is critically important. Upstash's Redis, well, you're not going to pay anything for this entire series, but that's the point of their serverless platform. It's incredibly low cost. Now, all of the code is also available on GitHub, so definitely check it out. I've got notebooks in there, and all of the source code will also be on there. And also, there is a challenge at the end that I will go through once you get there. So if you do have any questions, please let me know. My name is Justin Mitchell. I'm excited to take you through this one. Let's get started. We're going to start this one by setting up our virtual environment. If you've never set up a virtual environment before, this is going to be a rapid fire version of that. Of course, if you go on my YouTube, you can see a lot of different places where I set up a Python virtual environment. So the idea here is if you go into cfe.sh/GitHub, do a quick search for the SuperMe Photo AI API, you will be able to see that there is a starting branch. This is the branch we're going to start with, mostly because of requirements.txt. So the way this is going to work is you're going to go ahead and copy the URL. You're going to navigate to where you might want to store your project. So cd dev here. Then you're going to go ahead and do git clone of that folder itself. You could also clone it into a folder like I have. Then you can actually go in and let's say, for instance, it downloads everything. We can cd in here. Something you'll actually see is inside of the default one is there are some inputs, there are some images in there if you want to use them, or you can just do git checkout and then just do the branch of start, or just git checkout start, and then you can just do remove-rf.git and then do git init. It is now your code all together. Next up, what you want to do is bring in a Python virtual environment, which in my case, I'm using Python 3.13, but even I think Python 3.10 would work just fine. So we are going to go ahead and create a virtual environment just like that. Then, of course, if you're using VS Code, it might ask you, do you want to use this virtual environment? Which you will, but creating the virtual environment will go to this, and then you just do pip install-r requirements.txt. Now, if this was way too fast for you, check out many of my other series that go through this in detail. I will also have a link on that's a little bit more detailed than this for another series on how you can set up your virtual environment. Of course, if you're on Windows, the actual installation process might be a little bit different, or you're using WSL or Windows Subsystem for Linux. This is meant to be a rapid fire because this is kind of setting the pace as to what we're doing from here. Now what we want to do is basically turn an image into a zip file so that we can actually upload it into Replicate. Let's take a look at how we do that right now. Creating a zip file in an automated fashion is fundamental to fine-tuning AI models or training AI models for our own data. What we want to look at here is actually to do that with images themselves. Because of the model, we are going to be fine-tuning. Now, the way I'm going to do this is right inside of a Jupyter notebook to really build it out before I actually implement it in some sort of API service myself. Now, the first part of this, though, is to look at the basics of how to do the zip file part and also ensuring that the data we're using is going to be only images. Now, when it comes to Replicate and some other kinds of AI models, they might include a way to have a TXT file per image based off of the name of the image and stuff itself. We're not doing that. We're just going to go ahead and only have images in here and have no text file. So this process is fairly straightforward. Now, the reason I'm going to be using VS Code to run each cell, to run the Jupyter notebooks, has to do with the fact that if you have an LLM inside of your actual code editor, whether you're using GitHub Copilot or Cursor or Claude or whatever else is available, using it in the code editor itself is a big win versus using Jupyter directly, which of course you could always do as well, completely up to you. At this point, I want to go ahead and start this process. The very first thing is I need to navigate where this stuff's located in the virtual environment that I'm working off of, right? So, of course, selecting your kernel is one key part that you'll need to do. And of course, to run these cells, it's just simply shift and return or shift and enter that will run each individual cell. Hopefully, you're already well aware of how to use Jupyter Notebooks. If you're not, definitely check out a simple tutorial on how to get it done. The idea is we want to declare first off our notebooks mbs dir, the directory that I'm located in, which of course is pathlib.path. Now, typically speaking, if I was in a Python module, I would use the underscores of file. But since I'm in a Jupyter notebook, I can just leave it out and just do .resolve. This will give me my notebooks directory. So expanding on this, what I can do is just do .parent. This is now my repo directory where I have this project working. And then, of course, if I were to do /data and then slash inputs, I would eventually have the actual folder that has all of my images in here. So I recommend that you know how to do pathlib as well, because we're going to be working off of that. But the idea is from this point, I'm just going to go ahead and copy and paste all of those, including some sort of outputs directory that we will end up putting this in. Great. So now that we've got our pathlib here, our inputs dir is what we want to iterate through. So when it comes to pathlib, what's cool is we can say something like for file path in the path itself, or the directory location dot glob, and do a star here, and then we can print out each file path that's in there. These are still instances of pathlib, so each one of these we can actually do path.name, and we can get the actual file name itself. We can also get the suffix in there as well, as in the extension. We could also get the stem, as in the name without the extension. A lot of good stuff with pathlib. So using this here, what we want to do though is I actually want to guess what type this is going to be. So going back into my imports, I'm going to go above pathlib and import meme types here. And what we want is we want a guessed type, and then also the encoding we can bring in. We're going to do meme types.guess type. Now, the reason I'm doing this has to do with the file itself. So if I actually print out, let's do file.name, or filepath.name rather, and the guess type, what I want is literally just images. So if we go through here and we see all of the guess type, the first one is just plain text, and all of the other ones have image in it. So quite literally, Python is making a guess based off of the extension whether or not it's an image. So what we want to do, of course, is the ones that are images, that have image in their guess type, then we actually want to use those images. So what I want to do here is we'll go ahead and say to zip files, or really just our image, let's say image file paths equals to this. And basically we would then say something like if image not in guessed type, then we'll just go ahead and continue with the loop. Otherwise, we'll just go ahead and append that file path, right? And so right away, what we'll have is just one less file. It'll still be basically the same thing, but now it doesn't have the text itself. So there's all of our file path images in there and all that. So we want to work based off of that. I'm going to get rid of this print statement here. And so this is what I want to zip. I want to zip all of these files in here. This process is also pretty easy. So first off, we import shutil. Shutil is going to allow us to generate the archive or the zip file itself. Then we're going to also import temp file. Now the reason I'm importing temp file is because I need a temporary directory that I'll use to combine all of these files in, then zip that temporary directory, and then basically move it or save it as something different. So the idea then is we're going to go ahead and say something like we want to bring in our outputs directory. We want to make sure that that exists. So I'll go ahead and do outputs dir, make dir, and we'll go ahead and say exist OK being true, and we can say parents being true. The super nice thing about pathlib is this works on every system. This will make all of the directories. So if I open up my data folder here and run this command, right away I can see inputs and outputs. It's fantastic. With that in mind, I want to go ahead and do my zip out path, is what I'll call it, and we'll do our outputs directory slash images.zip. And that's where I want to store that file. So we can even check if it exists right now, and of course it does not, but I do want to use that path. So how do we combine these things together? First off, we do with temp file dot temporary directory, and then as temp dir. So we now have inside of this single with clause, or this single with block, we have this temporary directory. Once this block is completed, that temporary directory is marked to be deleted. It might still be available for a short amount of time on your system, but it's meant to be deleted at some point. So what I can do then is I can actually iterate through each one of these paths. So I can say something like for path in my image file paths. I could then go ahead and use shutil, of course this right here, and I can copy that file path. So I can do shutil.copy the file path, or make a copy of my inputs here. Again, this is a temporary copy because of this temporary directory here. then I want to bring it into my temporary directory. So the source and then the destination itself. Once I loop through all of those things, I can do shutil.makeArchive. Then I can grab the output path and I can use something called .with suffix and put in an empty suffix in here and then use a zip and then the temporary directory in here. So if you look at with suffix being 0, so let's go ahead and add some code down here with suffix and doing an empty string there, you can now see the output itself with no .zip file. If I were to comment that out, you can now see .zip. This is just a convenient way to make that happen. Of course, there's a lot of other ways on how you can do it, but when you make this archive, it's going to do the process of zip, so it'll add that .zip for you, and then it'll actually use the temporary folder that you're working with. Now, you could absolutely do this process with things other than a temporary folder. You could copy them into a folder you control, and you can see that temporary folder open. This is the preferred method, especially once we want to bring it into a web application of some kind, if we're going to do this in the web application itself. So let's go ahead and run this now. And so I don't have temp file defined, so let's go ahead and make sure that it is defined by running that cell again. And then we can run this now. And what we'll end up seeing is inside of our outputs, here's images.zip. And so what we absolutely want to check is that I can unzip it and that all of those images are definitely in there. That's the key here. Now, one of the biggest downsides of this current method is it actually isn't checking the images themselves, nor is it optimizing the images. This really just gets us to that first part of making sure all of this works. Now, I will say this data here, the inputs will be online, the zip files will not. So the inputs will be on the GitHub repo, but the outputs will not. That is something I'm going to add to simply git ignore. I actually recommend that you do the same. In fact, I would recommend you don't put in your inputs in there either, because you don't necessarily need to share that data. This is mostly for learning purposes and also for the next part where we improve this dataset zipping process. Building off of what we just did, we now need to validate these images before they become a zip file. Now, of course, we kind of validated them with this meme type of guest type, but of course, this isn't actually solving the problem for us because this is really just going off of the file extension. This is definitely valuable. If the extension's invalid, then we can just ignore it. But the idea here is we want to verify these images by opening them up. The way we're going to open them up is by using Pillow, also known as the Python image library. So make sure you install Pillow on your machine. Now, if you want to open up iPhone images with the HEIC extension, you're going to need to install this one as well, which takes a few extra steps to get it working on your local machine. In my case, I only have JPEG images or PNG images. If you're having a really hard time with this, then you could just take screenshots of the images that are of that extension, or an extension you don't necessarily need. Just keep that in mind when it comes to that if you run into that issue. Now, since I do have mine, I'm going to go ahead and do 2 imports here. The image ops one we'll look at in the near future, but Pill and the Pillow href, those ones are HIF, are ones I want to bring in. So I'm going to go ahead and add in my virtual environment here, and I want to make sure that these things run. Now, in my case, I actually did install this off the video as well as Pillow, but you want to make sure that those are available on your local environment, at the very least this one right here, for what we're about to do. In terms of the HEIC files, this is all you need to use or run in order to open those things up. So what we want to do here is we want to create a new function in here, and we're going to call this perform is image, basically taking in a path and basically adding in something like require can open being true. So what I want here is still this guest type stuff. I'm going to go ahead and bring this up here, and basically this is where I'm going to go ahead and run this. In this case, instead of doing continue, we would just return false here. Now, another thing that's important about this guest type or the meme types is if for some reason it actually fails. If it does fail, I'm going to go ahead and bring guest type being just an empty string. So having that try block is really important. Naturally, we also need to make sure that we're using the correct path. And then, of course, if it does work, then we would just go ahead and return true for each path. So I'm going to go ahead and bring this in now. At this point, what I want to do is I just want to verify is image and basically bring it in that path. It's going to bring us true or false in there. And then we'll go ahead and say if is image, then we'll go ahead and do that. Or if not image, then we can continue it. Either way works fine because they're both conditions that work. So of course we can go through this process now. Let's go ahead and give that a quick run and just make sure that we are still getting basically the same image paths in here. And I think that I am. Obviously I could count and verify, but I actually am not quite done with this function right here. What I want to do is if the guest type is an image, after that I want to verify that it can be opened if require can be opened is in there. So basically, in other words, I'm going to go ahead and say, guest image being equal to whatever this is, and rather not, we would just say something like that. So if not guest image, then we would go ahead and return false. Then what I want to do is if guest image and require can open. Now I want to go ahead and use pillow to see if it even works. So the seeing is really just using the image class to open up that path. And if it doesn't work, then we just return back false. So any sort of exception here, if for some reason Pillow's image class cannot open the file, it's just going to go ahead and say false. The nice thing that's about this is if for some reason you don't want HEIC files being supported, you could actually just ignore this altogether, and in which case it would then ignore that file. It's not a file this system would be able to open, which I think is really nice. So it will ignore those. But every once in a while you probably want to have this support so it's easier for your end users if you're going to build this into an API like we are. So at this point I'm going to go ahead and run through this process, and it's identical. I still have the require can open in here. Everything works just fine. So there is no exception in here. And of course we could also say image in here equals to that, and we could print it out to see if it is being opened as a pillow image. And what we end up seeing is, there we go. There's all of the Python image library stuff. So what this hopefully also shows you or tells you is not only can we validate the image, but we can also optimize it. Now there's actually nothing I need to change with the rest of this because this is just an image validator now. So all we need to do is add one more feature into our loops here of optimizing these images. One of the things we want to ignore is large images, or maybe not ignore them, but resize them. We also don't want to have the image metadata in there for privacy reasons. Images by default often have GPS information on them or information about their camera. We can strip all of that data away, and we want to do that with the optimizing portion. Now we're going to optimize each individual image. We're going to do this by using the Python image library and a function I'm just going to give you. Going through this process can be a little tedious. That's why I'm just going to give you the function itself, because you may or may not do this process yourself. Now, the idea here is we want to remove all metadata from the image. Then we want to optimize the file size and preserve as much quality and transparency as possible. So in other words, we're going to go ahead and put an input image in here and then have an output with that optimized version. That's a copy. It's not going to modify the original. That's a key part of that. Then we also want to have a max size. The actual size of the image will make a difference when it comes to training. So the bigger the image you end up using to start with, the better, right? You want to have a better resolution image initially, then you optimize it to bring it down based off of the training as you see fit. So that's an important part of this that I think will help improve over time. I also have to imagine the AI tools that go in the future might only take one or two images of you in high resolution, or maybe not even high resolution, and be able to produce stuff, which will be really interesting when that happens. But in the meantime, we're going to use this method. So this function itself, I already went ahead and copied into basically that same Jupyter notebook in here. And you could go line by line and see exactly what's going on. It's basically going to go ahead and give us our input and output. Once again, the output is going to be a copy of the original. It's not going to modify the original. That's the important part itself. So we open and create a copy of it. Then we go through all of the processes, including making sure it's rotated the correct way. It has the right orientation, which does tend to happen sometimes where it's the wrong orientation if you're using Python image library. Then it resizes it as it sees fit, as the image needs to be resized. It keeps the transparency mode. So if you're using a PNG with a transparent background, it keeps that mode going on, and then it saves the correct format or the best format given all of the things related to the image itself, and it saves it to the output as well. So the reason that we have this has everything to do with the fact that we want to have any kind of image coming in, and we don't want our zip folder to be massive. We want it to be as small as it possibly can be, which means that all of the images inside it are as small as they possibly can be. This might cause issues with the original images, which is why we also want to have a new folder, and we could say something like ready, that are these optimized images. So basically we take the raw inputs, we put them into ready, and then we output them to a zip folder of some kind, right? And so that's the goal of this one. And so let's take a look at how that ends up happening. So we've got our ready dir right here. So I want to send them to this ready directory. This process is actually fairly straightforward. First and foremost, in this actual for loop right here where we're verifying the image, we could absolutely put it in here. So the idea then is if we look at the output image itself, we've got an output path that's coming through in here. So that means I can use this function on the original. So let's go ahead and say that we want to have an output path, as in where we're going to store it later, which is going to go based off of the ready directory. So let's go back in here. We'll go ahead and do ready dir / and then the file path.name. This most likely will be the output path, at least somewhat. So let's go ahead and do the start output path. That's what we'll call this, as what we'll end up using it as. Then we'll go ahead and run the command itself, or the function itself, to create these images for us. So we'll go ahead and come in here, and let's go ahead and run this right here. So the input path is going to be this file itself. The output path is going to be the start output path. The final output path is what's going to be actually given to us. Okay, so the final output path is then what we will probably want to append itself. So let's go ahead and run this function here, and let's see if it ends up creating everything for us. If we look inside of ready, it's going one by one, and it is going to optimize these things. Now, it's not necessarily going to be super fast because it's going to rescale each individual image itself. Think of this in terms of if you were using something like Photoshop or Apple Preview or any other thing that can actually resize images. Sometimes it goes really fast, sometimes it does not. This is going to take some time. This is also going to help our performance overall with our images. Not every single image is going to be a big one that needs to be resized, but it's important to see that it can be. Now, one of the things about the outputs here, I'm actually going to go ahead and delete this folder of images. That only came up because I unzipped this original zip file itself. This time the zip output, I'm going to go ahead and do something like optimized in here, just renaming it something different. But what we should see at the end of optimizing all of these images is the actual new image file paths will have that ready in there as we see fit once it's actually all done, which it shouldn't take a whole lot longer. And there it is. Now it's all done. There's all of our ready images. Now, of course, we can have our outputs directory. If we needed to recreate it, we totally could. Now we can do our zip file the exact same way as we were before. And there's the optimized version. So let's go ahead and take a look at the difference in sizes. The unoptimized version and then the optimized version, it's almost a third of the size. So it's quite a bit different. And it also depends on what images you're using. If you use massive images, it's going to be a lot smaller, more than likely, than the other one that wasn't optimized, which is exactly why I recommend highly to optimize those images as best you can. Again, the AI itself is going to do a really good job. I think it's only going to get better at training from these images, from this data set. So we are in good shape now to then start the process of actually training our images themselves. Now, one of the challenges I want to give you right now is to turn this optimized image notebook into a reusable module that you can use inside of FastAPI, which of course we will build out soon enough. But I want you to think of that on how you might go about doing it with users in mind. Because right now, we don't have any users. We just have our single user. So the challenge you'll need to undertake is how to turn this notebook into one that takes into a user on some form, whether it's a user ID or a username. Now at this time, I want to update my gitignore to get rid of those ready folder itself. That's another thing I don't need. I just need those raw inputs for now. Now we're going to train our own custom image generator. Technically speaking, this is going to be fine-tuning a pre-existing model. The model we're using is an open source model called Flux. It may not be the latest version of Flux, but it is using Flux. Flux itself as an open source model is great. It can do all sorts of things in here, as you can see from using Flux altogether. Now, when it comes to customizing it with our own images, we still have a lot of those other capabilities with our images as a key focal point to it. So the way we're going to train it is by using Flux Dev LoRa Trainer. So go ahead and look this up on Replicate or use the link we have, and you can see that there's this training process here. Now, before I start this training process, one of the things I want to validate is that my ready images, or the images I zipped, actually are all pictures of me or the person I'm trying to use. And so we want to go one by one and just take a look at them. Do these look like good images that are training one single person, or is there a big group? Am I wearing sunglasses? All of those sorts of things. This might not be a great image to train on because there's a lot going on in here and there's something maybe obscuring the face. But the idea here is you want to go through each one and make sure it is at least a bunch of images of a person, because that will actually change how your training does. You also want to make sure that the images are big enough, which I think is like 1080 by 1080. That's the goal pixel that you'll want to have when you go through this process. So after you do all of that, it's time to actually start the training process. Now, a big part of the reason I don't want to automate this yet is because I want to make sure the outputs from these early ones are good, if not great. The other part of this is if you were going to start doing this as a service, you could tell your users it's going to take anywhere from 24 to 72 hours before I deliver your model, just because you might need to train it multiple times before you think it's really good or something you would want to share with them. So at this point, I'm going to go ahead and create my model. Just go to that link. Of course, you can always search for it. Then into the destination here, we're going to go ahead and create a new model. Now, whatever you name it here is what's going to be unique for that data set. So in my case, I'm going to call it superme-justin, and I'll go ahead and say V1 or something like that. So basically, superme being the name of the project, Justin being the name of the user. In my case, it's me, of course, and then V1 being the version you want to name this. Now, you can actually train it inside of whatever you do here. So you don't necessarily have to do V1 in here, as you'll see in just a moment. Next up, you can choose whether or not it's private or public. I'm going to leave it as private. Then, of course, our input images here. I'm going to go ahead and upload the zip file that I created just moments ago. So navigating into our project here, into our data, into our outputs, and then image optimized. I'm going to go ahead and open that up. And this shouldn't take too long to actually zip. Next up is the trigger word itself. From my tests, if you use actual English in this, like if I said super me, this will actually add super as part of the prompt. Now, this will become very clear later. I'm going to leave it in as their default of just simply talk, T-O-K. Of course, you could always use other ones if you want, but using their default's a good idea. I'm also going to auto caption. This is not something I'm going to worry about at this time, but it uses some advanced LLMs to help auto caption this stuff out as well. You can add prefixes if you like. The training steps, I'm going to leave the defaults pretty much all the way down. You can also deploy this to Hugging Face if you wanted to, but that's it. I'm just going off of those things, and then we're going to go ahead and hit Create Training. This will take anywhere from 15 to 25 minutes. Obviously, if you're a little bit more advanced, you can change all sorts of things about the training process. But this right here, I just said, yep, go ahead and charge my card after this thing's done. That's kind of the idea with this, and it's going to be true when we want to use this model as well at some point. Now, the cool thing is you can run this model locally with their built-in process. That's not something I'm going to do at this time, but there is a way to run it locally after it's been trained. But it also would require you to have a GPU of some kind. So I don't always recommend to most to use, the already trained version on your local machine, because it's probably not going to be nearly as performant as what Replicate will end up being, because they have so many GPUs and they have a bunch of systems in place. The one thing that you might consider doing is uploading it into Hugging Face, which of course you have that option when you train it. So once this is all said and done, you will have your new API endpoint, your own new model that you'll be able to work off of once it's all complete, and you'll be able to see it under your own models, which of course I already have one in here. So yeah, I've got a version also coming in here, as you can see, which is pretty nice. But I'm going to let this finish before I start using it. The point of this was to get the training going and using the data we have, and just some background as to what's going to go on going forward. I will say this current trainer is likely not one you're going to use in a year from now. You're going to probably use a much different model to train on top of. This is one of another reason to have your original inputs. At some point, maybe you will change how Replicate works and want to use those original data points in there as well. After about 20 minutes and about $2, I actually now have a trained model. So I can go into my models here and I can use Replicate's UI to just play around with this. We've got a playground that we can do all of this with. Now the key thing is the prompt itself often needs to include talk. Now sometimes it will actually still generate it based off of your likeness or whatever image you trained with without talk, but most of the time TOK or whatever trigger word you used will be in there and it will work well. So we can go ahead and try this out, and you can use something like a photo of a talk adult man. I've had the best results when I declare that I'm an adult man. If I were an adult woman, I'd use that. If I was a child, I'd use that as well. So being more specific about it, I think, yields better results. But this is that prompt engineering stuff that you can go through. You can also use an image as a reference image that it will kind of like use in some cases, which we'll see as well. But if I go ahead and run this, and then if I were to run it again, you can go ahead and go back into your dashboard and then just click on models. Go ahead and click on your model again and then run it again. This one is a little bit different than what we just had. You can run that. This is now two instances that are running at the same time. One's going to be pretty quick. The nice thing is you can go into predictions and you can see all of the ones that were run. So you can always re-reference these things in the future. It's not like one off and then it's gone, which is super cool, both in terms of programming, but also in terms of if you are trying to build out a service for someone else. So if we look at the most recent run, I see this is the first one. That looks a lot like me. Now, I don't have a suit like that specifically, but I think it actually looks decent, right? It looks like actually surprisingly really good results. Okay, so that of course is the actual prompt itself for that one. Obviously you can play around with all sorts of prompts in here. And then the more recent prompt that I did was looking like a slob. To me, that doesn't really look like a slob, but whatever, the prompt's not that great. However, that looks like me, and that also looks like me wearing a hat. I'm shocked how good this is. And the cool thing is, this is like the beginning of how good it's going to be. It's only going to get better from here. Great, so now that we can play around with it in the web UI, let's bring it on over into Python. So what you'll see here is a bunch of examples on how you could go ahead and run this. And in this case, it actually included the prompt with it. If for some reason the prompt's not in there, it's just going to be a key value pair that you'll end up using. So Replicate itself, the actual Python package, we installed with requirements.txt. So I already have it on there. So we'll go ahead and start with the code that it has. Now the first thing is I'm going to go ahead and bring in a new cell here for Replicate. And I'll see that I can just go ahead and try to run this. And so what's going to happen is, of course, I don't actually have the API key in place. It's not there. I mean, maybe it's going to run because I've been testing this and it's trying things out. Maybe not. I don't know. It's hard to say. Looks like it actually is running though. But more than likely you'll have an error. So this is actually not how I want to run Replicate in my notebooks. So what we do is to figure out how to run with our own API key, to inject our own API key, we want to look at the package itself. Right away, we see that we've got a default client in here that's initialized in the init method. So when I go ahead and import the entire package, it's initializing right there, and it has all of these other features. What this is telling me, this default client, is that I can probably initialize my own client by importing it from here. And so that's actually what I would try out, is import my client just like that. Now what I'll do is I'll go ahead and say something like replicate client equals to the client itself. And so that is the API service I'll end up using. So with this in mind, I want to bring it back and actually bring in my API key. So something like my replicate API token, and put that in with the configuration item and go off of the Python decouple now. Once again, that was in requirements.txt right there. So the reason we have this API token is to prepare this for a couple things. One, to not leak API tokens when we don't need to. You never should leak API tokens. Two is to prepare it for when we actually bring it into a web application and building out our own FastAPI application or a Django project or whatever you might end up using for it. So in this case, I'll go ahead and do .env, and we want to build and bring in our own API token here. So the way we do that is, of course, going back into Replicate, going into the dashboard, clicking on your username, going into API tokens, or of course, you could go into this URL here, and then you can generate a token. So if I delete a couple tokens in here, there we go. I'm going to go ahead and generate a new one called superme-token. You should create one as well. This right here, we'll go ahead and copy, and I'm going to bring it into this .env. Right now, I have exposed this API token. This is not good practice. So of course, I will need to roll this token to make sure that it is secure and hidden. That is the key reason why we use these environment variables like this, especially in notebooks like this. Now, their documentations for Replicate has other ways of approaching this, but this is the method I'm going to use. With this in mind, I'm going to clear all outputs and I'm going to restart this again. And now I'll go ahead and use this client as API token and pass that in. Great. So this should now give us that actual client. The next thing that I want to do is I'll go ahead and say my replicate model. Now, in this case, I would probably want to put it into a environment variable as well. But I'm going to go ahead and use a default value in here too for the notebook itself. That default value is going to be this value right here. So the first part of this one. And then I'll go ahead and do basically the same thing and just go ahead and say something like replicate model version. And let's go ahead and just change that. Simple enough. There we go. And then of course the model version is all of the other stuff that's in there. Once again, I'll use a default value. So now I'm going to go ahead and say something like my API endpoint or my model. We could just call it the model itself. And that's going to be based off of those two values with a colon in between them like that. Now again, I'm trying to prepare this for a web application to be used later so that I can change these things on the fly as I see fit. So I'll go ahead and say something like model version, string or something like that, or replicate model, however you want to name it, you want to make sure that it is consistent with how they have their API. Next up, I'm going to go ahead and bring in my prompt, right? So right now, I'll just go ahead and use the default prompt that's in here, which this prompt isn't great. So let's go ahead and change it to something a little bit more dressed up, right? So an adult man dressed up for a professional photo shoot. Great. So now we've got our prompt in here. Now you can, of course, change all of the defaults that come through. I'm only going to change two things. That's going to be my output format. I'm going to have it as a JPEG. And then my number of outputs, I'm going to go ahead and increase this to something like 4. All of these other ones, I'm not going to worry about right now. Feel free to do it as you see fit. Next up, instead of calling this output, I'm going to go ahead and say responses. And responses. The reason I have an S there is because this is going to always return multiple responses. But now what we've got is we can run all of this. And what I should be able to get if I run every cell is I should be able to get some responses in here. Now, those responses are going to all be instances of the actual model inference itself. So in other words, if we actually go back into our dashboard here and we've got all of these different predictions, these predictions will be a good example of what we'll get back, right? So we get some outputs in here. There's one that looks like me. That is definitely not a picture I never ever took, but I feel like it could pass really well. And if you used your own images, I'm really curious to hear if yours could pass really well as well. So this actual process of generating an image does take some time. This time is going to only get faster over time. I'm positive of that. But what we see here is a file output, a file output, a file output. There's going to be 4 of them. It's going to be based off of the number of outputs here, right? So if I do the length of those responses, I should be able to see that, and it's exactly 4. So if I grab one of them, I can see that there is this stuff here. So normally what I would do is just use dir to see all of the available methods I might have on it. And of course, the available methods are down here at the bottom. One of them being URL, read, right? So those are what we could use to actually generate some files here now. So what I want to do then is I want to generate a file. Now, the way I'm going to do that is by using the generated dir. So that directory here is where we're going to output some files. And I want to make sure that they are unique. So there's another thing that I'm going to do here. So first and foremost, we will go ahead and do for I and output and enumerate the responses. We can now print out I and output, which will give us basically the same values that are in here and some sort of iteration that's on here. Now, the actual output name or the actual file name, I could say something like file name is equal to, well, it's going to be i.jpg. Right, so that is certainly a way I could do that. I also might include the prompt in there in some form. I've seen this done with other AI generators where they'll use the prompt as part of the file name itself. I'm not going to do that. Instead, what I'm going to do is I'm going to go ahead and generate a session each time I generate a response at some point. I'll go ahead and say something like session ID equals to random.randint. And we'll go ahead and do between 1,000 and let's say like 40,000 or something along those lines. Let's go ahead and make sure that we are also importing random to allow that to happen. Okay, so there we go. Now we've got our session ID here. And of course, we're using JPEG because of the output format. All of those things are rather important. Okay, so now that we've got this is going to be the file name. Let's go ahead and do the out path being, well, the generated directory of that file name. No big deal. That, of course, does not exist yet. We need to make it exist. The way we make it exist is by saying that we're going to go ahead and open this. So with open the out path as write bytes, and then we'll go ahead and say as file, or let's go ahead and just use f. Then we can do f.write as in file.write. We want to output and do .read. So basically we are reading the file itself, and then we're going to go ahead and output it to those images. We run this, and now we should see these generated images of me. And I'm still shocked how much they look like me and how accurate a lot of this is. This is so cool to me. Now we're going to go ahead and use a reference image to do basically the same thing. So we've got here is a picture of Tom Holland's Spider-Man. Of course, this is meant to just be a reference. I don't think it's going to replace my face. It's not meant to be a face swap. It's really meant to just use this as reference. So hopefully we can build out something that's pretty interesting. So I went ahead and duplicated the previous notebook, but now what I've got is a location for this referenced image. So all we really need to do here is maybe change this to reference image path and then do something like we'll just go ahead and say image equals to open that reference image as read bytes. We're now going to pass this in as another input for the image itself. After we get that input, we can go ahead and close out that opened up image. So let's go ahead and give that a shot with this and this. Then of course, we're going to go ahead and get some responses here. I don't need to see the length. Then we'll go ahead and iterate through all of those things being generated. So this is actually why you now see maybe this session ID here is when I go through generations, I can see new generations coming through. There's a lot of different ways on how we can approach that, of course, but I want to go ahead and let this actually finish up. I don't know if it's going to give me anything different than what I've seen before, but maybe I'll go ahead and photo of adult man dressed up as Superman like that. Or let's do Spider-Man because that's the image itself. So Spider-Man. And also we want to see if it does it without the mask on. So this will be the next one I'll run, and I'll do that off the video. So it's running the model again, but before I even take a look at it, what's cool is as soon as it started using the reference image, it gives a full body of the image with a city in the background, which is essentially what the reference image looks like. This isn't exactly a city, of course, but the AI itself is just kind of going off of what's given. Now, a lot of these pictures are still really funny to me, but it is pretty cool to see that the reference image is definitely working. I mean, this looks a lot more like that. Although it's a man dressed up, it's still taking the original prompt itself. Now, I'm really curious to see if it's going to generate something with, me in as Spider-Man, basically. But if we take a look, there's Spider-Man. That's not exactly what I was looking for. Closer, which is funny. Also closer. But yeah, it doesn't look like there's one without the mask on. So this one is also funny. All of them are pretty funny to me because it's me. But the idea here is we see this reference image now, and sometimes it's really good, sometimes it's not. I have to imagine that these things are only going to get better with time and probably a more robust prompt itself. But we now see that we can use a reference image and get a lot of really good things from it, whether it's just something like this, or if it's something like this, or it's a big mistake where it's something like this. This looks really, really silly. But overall, I'm really impressed with how much this works. Now we're going to trigger a background generation. All this means is that our application will not be blocked from moving forward. Now, the reason I'm doing this is for when we move it into an API service, we will be able to automatically generate things, then check back when we need to. We don't need to block the application itself. We'll talk about that more when we get there, but right now we just want to play around with it in a notebook. The way this works is going to be very, very similar to what we've seen before. So, of course, we run a few of the defaults that we have already set up. We get our replicate client, and then we've got a lot of our inputs going on here. So the way this works is we're going to actually go ahead and create a prediction, which I'll just say pred, and this is going to take the replicate client, and it's going to do .predictions.create. Now, the way this works is a little bit different than run. What we need to do here is we need to grab the instance of the model itself, which actually takes the client, and then we do .models.get, and then we use the replicate model, just the model, not the version itself. So we bring that in. Then we get the replicate version, which will be based off of that model. And then we do versions.get, and then the actual version number itself. So it's a little bit different in terms of how we set up a prediction, but then we actually use this version right in line here, just like that. And it should be just simply version. Great. So this is the baseline of starting. It's very similar to what we saw basically up until this point here. The next part is very similar as well, but we probably don't need model in there. I think we just need these three arguments in here. So we're going to go ahead and put those in as our inputs just like that. Now, of course, you could always change the prompt itself, like let's go ahead and do something like a sports photo shoot, for example. And I'm going to go ahead and delete my generated folder itself because we'll look at that in a moment too. So now if I run this, what I should see here is a prediction, and the cell should finish pretty quickly. But it looks like I've got a invalid argument in here, so maybe this should be input, not inputs. So we go ahead and change that to what it should be, and it takes a second versus several seconds or 30 seconds in there. So it happens really, really quickly. So now what we can do is we can look at this prediction. We can look at the ID. We'll come to that in a second. We can also take a look at the status. So this is where we would do polling, P-O-L-L-I-N-G, to check what's going on with that data. Now, what's cool about Upstash is we can actually use something called QStash to also help us with the polling process. Because remember, it's going to take somewhere between 20 and 30 seconds for this whole thing to finish. And once it is finished, then we will see the result in here as well. Now, there is one more thing about this that we can do is we can use the prediction result in here, and we can say something like pred lookup, and this is now predictions.get, no longer those inputs in there, still using our replicate client, so we have all the authentication, but now we can actually get the prediction ID, so pred ID being equal to that ID there, which of course is the same as what we've looked at. And now we can actually take a look at that status. This is where we can do that polling, and however many seconds went by, and now we can see that it's fully ready to go. So this prediction lookup and this prediction itself, both of these things should be exactly the same, these same results. So if we take a look at output, for example, here, we should have two URLs. Part of the reason I have two URLs is because I changed my output to 2. So I recommend having more than one output. We will take a look at one output in just a moment, but now we've got this output here of our URLs. And of course, if I were to do the pred output, I should get something similar, but for some reason it's not actually coming through. I'm not sure why. Maybe it's because we've got the lookup going on. So let's go ahead and just go back into simply the lookup, and there we go. So this is the method I'm going to use anyway. I want to go off of the lookup itself. Now, something that's interesting here is we have two different IDs, two different things going on with this. This is something we'll have to account for when we bring it into FastAPI to actually generate these images for us. But before we get there, I actually just want to use something called HTTPX. HTTPX is just like Python requests, but this one gives us async support, which we'll end up using on FastAPI. So that's why we'll go ahead and take a look at this right now. So I'm going to go ahead and import HTTPX and also import random. So the idea here is something similar to when we actually stored our data. So it's going to be very similar to this right here. So we can always copy that and bring it in. But the thing is, we are actually going to now enumerate the prediction lookup outlooks. So basically say something like the URLs or the pred URLs is what I'll call it, is going to be equal to that output. There we go. So that's what we actually want to enumerate through. So the way we're going to do this is by using HTTPX first. So we'll do with httpx.client as client, and then we'll go ahead and tab these things over. Now we're going to go ahead and grab the actual response for each one of these things. So each iteration here, we want to go ahead and do a lookup. So we can still use the file path name and the out path. Both of those things are still great, and even this open will be great in a moment. But what I want is I want to do a request, which is we can say a res as a response. I don't want to accidentally put response up here. I'm trying to name these variables how I would actually use them. So I'm going to go ahead and do client.get of that URL. Then I'm going to go ahead and do res.raise for status, which means that it's going to go ahead and error out based off of the prediction URLs. Now notice I actually did URL here. This is not an output anymore. It's now a URL. So we can get the request here. This is actually doing the lookup. It's doing an HTTP request for that URL. Then all we really need to do is take that request and do .content, and that will actually store that data in there for us, just like what we've seen before. So now I can run this, and hopefully what we end up getting is this data coming through. It's attempting to, but it's saying that the directory is not found. So let's go ahead and rerun this cell to make sure that folder is in there like we did before. And I'll go ahead and rerun this again. This time it should actually output all of those images in there. In this case, it's 2 images, which, that actually sort of looks like me, which is kind of weird. Still weird. Okay, so now we've got a way that we can start using this inside of FastAPI. The big difference here, though, is the FastAPI will not write it to a local file, most likely. You could do that, but instead it'll be doing a lot of these same things and streaming this data back. So we will see this again, just in a slightly different setup. In about April of 2024, I brought out this course called SaaS Foundations. This was a Django tutorial building out the bones of a SaaS application. What we're going to do now is enrich this application indirectly. That is, we are going to build a FastAPI microservice as a proxy to the replicate API. Now, the reason I'm going to do this is so that I have one central place to call replicate for my services. Now, I won't always want to do this, but sometimes I will, because it's really hard to know how often I'm going to be generating images. The nice thing is replicate's there and we get charged based on how much we use it. So this API itself, I would probably want it to be serverless. I would probably want it to scale down to 0 when I can, and I want all of my systems around it to also scale down to 0 as necessary too. So for that reason, we are using Upstash Redis as well as our primary data source so that we actually don't have to also enrich this with some sort of SQL database. Instead, it's just a middleman service that's going to handle all of this stuff related to replicate. Now, of course, if you want to expand what we're going to do here and make it into a full-on web application itself, not just a microservice, you totally can. That's going to be up to you. But that's the goal to me at this one. And at this point, for this particular service. So let's go ahead and take a look at how we're going to go ahead and do this now by jumping back into our project here, creating a folder called source. Inside of that folder, we're going to go ahead and do main.py. This code is coming almost directly from FastAPI. I think FastAPI uses app instead of SRC. I like using SRC for all of my Python projects as well as any of my other JavaScript and related projects too. So the idea here is we want to build out a FastAPI application. Now, this is actually really easy to do. First off, what we need to do is come in here and say something like from FastAPI, import FastAPI, and then just declare the FastAPI application. And then we do app.get, and then the home page, and then we define, I think they call it read index, and then we return back something like, hello and world. Great. So what happened with FastAPI is it's improved over the years, but what you used to do to run this is you would navigate into the SRC folder, and then you would do uviacorn, and then main app -- reload, and that's how you would run it. And so what it's doing is it's looking in the main module for the app. That's what's going on here. If you called this ABC, that would need to be ABC. App itself is quite literally the variable of app. Once again, if you change that, you would need to update it. So this is how it used to be done. This has actually changed because FastAPI has gotten very, very popular. So now what you can do is just run FastAPI. This actually has a command that you could use. Notice I actually don't have the command line tool in here, and it's actually giving me a warning for it, which means that in my requirements.txt, I could just come in here and make sure that's installed. Now, of course, if there were any issues with running this application just a moment ago, you're going to need to install FastAPI anyway with what I'm doing right now. So it's certainly possible that through my tests, I actually installed it in the past. So yeah, that might be why mine worked and yours may have not. But now with the actual source running, I'm going to go ahead and run now that FastAPI command. If I run it here, I can see that there's a few options. The main one is going to be dev, and then we can do main.py. And it's actually already really intelligent and does all the things it needs to for FastAPI. And it's still using uviacorn, which is great. And I think the production version is FastAPI run, which is also really nice. Production mode. Cool. So we have two different options to run FastAPI now, and this has definitely simplified the process. I think in production, you'd probably still want to use gunicorn with uviacorn, which is something I've covered elsewhere. But the point here is to have this hello world. Of course, if you want to take it a little bit further and use their full-on hello world from the FastAPI docs, it's going to look a little bit like this. Let's go ahead and build out our helpers module. So inside of SRC here, I'm going to make a folder called helpers. And then inside of here, we're going to go ahead and do init.py. And we'll go ahead and create another one called replicate.py. Since the actual Python package is replicate, I want to do an underscore there for it to be my own version of it, essentially. Now, the idea here is going into my notebooks, the trigger background generation. We want to do a number of things related to this. The first one is going to be bringing in the imports. I don't need pathlib just yet. I'm going to go ahead and bring in those imports. Then we'll go ahead and bring in the API related stuff. So we'll bring that in just like that. Next up, what we want to do is get the client itself. So I'm going to go ahead and copy this, and we're going to create a function called get, replicate client. And all it does is return back the original client command like that. Now, to do this efficiently in a web application, especially inside of FastAPI, would be to use something called from functools, the LRU cache, which basically means that we don't instantiate or create a new object of this many, many times. It will happen one time when we call this function one time, and then it will stay in cache so we can reuse that over and over. So with this in mind, I can then go ahead and create out my something like generate image function, which would take in a prompt of some kind, and it will return back some data. Now, how we generate this is going to go based off of that background process of these predictions. So essentially like this. So what I want to do though is I want to bring in my input arguments here, and I'm going to bring those in, right? That has our prompt and our args here. I'm going to go ahead and think about how I want to grab the client, or actually how I want to run the predictions themselves. So going back into that notebook, we see we've got our model and prompt in here, but then we also have these two things for the actual replicate model does a lookup on the API, and the version also does a lookup on the API as well. So these are actually good candidates for also caching. So I'm going to go ahead and do the LRU cache, and this one is going to be get, replicate, model version, something like that. And then we'll go ahead and let's get rid of that right there, and we'll go ahead and return something in there. Now that something, of course, is going to be based off of those two values, the model and the version itself. Then, of course, the client is going to be based off of that. There we go. And I could just go ahead and keep the same naming convention and then bring back that version. So having that version is really nice so that we can then come down to this prompt and we can go ahead and say our replicate client again. And I can do something like get that client. So let's go ahead and do this right here. And then we'll paste that in, and then the version itself. And we'll go ahead and paste that in as well. Now I'm going to go ahead and call this rep version again. Now the idea here is we want the client and the version. So the first time that I call this, it gets cached. So when I call it again, it's not reinitializing the client. It's just going to do it the one time. So this might feel like it's redundant where you should pass the client in here, but it's just not necessary. You also don't actually have to cache the version if you don't want to, if for some reason that makes most sense to you. But I want to cache it so it's all there and it's ready to go. Next up, of course, is just doing the prediction, which takes in all of those things, which now we can just do, the pred equals to that. And all I really want to send back is probably the prediction ID. So pred.id, and I'll actually call this just simply ID, and then maybe the status itself, and then pred.status. And that's it. So all of this stuff is going based off of everything we've done before, of course. So now we've got this generate image here. So in my helpers init, I'm going to go ahead and do from dot replicate or underscore replicate. I'm going to grab that generate image, and then I'm going to put this into all here. And then we've got our generate image here. Now inside of main, I should be able to import helpers, and somewhere in here, I'll be able to do helpers.generate image and run whatever image generation prediction I might want to run. I'm not going to do it just yet because we need to make the endpoint. The point of this was to have these helper functions in here. Now, I want to make a few things really clear. Number one, these API tokens themselves, all of them will have to be either in OS environment or the environment variables or in .env. Having these defaults can be nice, but obviously you won't have access to my defaults. So it also might be a good idea to not have defaults in here and just make sure you set them at runtime. So basically getting rid of these defaults, which is exactly what I'm going to do. I'm going to bring in my new ones, just like, well, we can actually even just copy this whole thing and bring those in and just get rid of config in there and just pass in the default itself that we had before. This also will help error things out. So if for some reason you forget to set the default values or you forget to set all three of these values, then you will get an error on your application itself. Now, the nice thing with .env and also Python decouple is you don't actually have to put quotes around them. You can just do this. So back into the replicate helper function here, I'm now going to get rid of those defaults in there. And yeah, so now those configurations will absolutely have to be in here. Now, what's cool about this too, especially if we start implementing serverless versions of this, we could have this FastAPI application, once it's all said and done, we could have one for each one of our users if we wanted to. We could also modify things a lot to where we could then pass in our generate image, we could actually pass in two of the arguments, which would be these two right here, most likely. You could also pass in the token as well, which actually does change the caching a lot, which is something outside the context of what we're going to do here. But overall, I think this is actually pretty cool and pretty simple to set up now that we've seen all of it done in the notebooks. Now we're going to create the FastAPI endpoint to generate an image. Now, the way we're going to do this is, of course, get rid of this other one that we had, and we're going to go ahead and define a new function called simply create image, and, well, it's going to be app.post, and we're going to go ahead and do generate. Now, what it's going to return back, of course, is going to be related to the helper function itself, which in our case, it's actually going to be the pred result, which is going to be equal to that. Otherwise, it's going to do something different. So the actual result itself will be based off of this here, which is a dictionary. So I can just return back that result, which would give us JSON data coming back. If this doesn't work for any reason whatsoever, we're just going to go ahead and raise an HTTP exception with a 500 error. So that's all we need to do is say raise HTTP exception. The status code is 500, and then we can add in some detail values here related to the exception that's happening. And I'm going to go ahead and put it as E. We put it in as a string here, just like that. Okay, so as it stands right now, this is not going to actually generate an image because we have a problem with our prompt. It's empty. So we need to bring in the prompt. Now, the way we're going to do this is by using something called Pydantic and a image prompt request, or maybe an image generation request, something along those lines. But the idea here is this is going to be a schema that we'll bring in. This schema can be validated on the request. So we pass it in as our data, and it's of that data type. So when we do send a post request here, we will pass in data with the prompt in there, and in which case we can just go ahead and say something like data.prompt, which is this right here, of course. Now, one of the things in our case that we want to be aware of is the prompt may or may not have the value we want in it. We might not have that one special key that we need to bring in, which we probably also want to add as well. So I'm going to go ahead and do from Pydantic. I'm going to import the base model here, and we'll go ahead and throw that in just like that. Great. So that's going to validate the data for us when we actually run it, which we'll take a look at in a little bit. The generate image function in here, we've got the prompt, and it's just going to be the pure prompt. So what I want to do is I want to go back into Replicate, right? So let's go into our dashboard, into our model, and just take a look at our model itself. And what we should see is the trigger word in here. So I'm going to go ahead and say something like enrich and trigger word being true, and then our trigger word being talk. Now, once again, this trigger word could be an environment variable if you wanted it to be, but I'm going to go ahead and add these two items in here for when we generate the prompt. Now, the reason I'm having this being default of being true is I'll go ahead and say if the trigger word, or if the prompt is not in have the trigger word, basically if the trigger word is not in the prompt, then I'm going to go ahead and raise an exception and say something like the trigger word itself was not included, right? Let's go ahead and instead of saying enrich, we'll go ahead and say require trigger word. We could totally enrich it, but now that we've got this exception in here, when we do try to create a prompt, that will raise an error with what's happening, what's missing from that prompt, which of course has the trigger word itself right in line. Then of course, if it does have that trigger word, it's going to do everything else and return back everything in there. Now, of course, we can modify this exception. We can make it our own. We can customize the name of it and have a default message. But I think this will work in the short run. In the long run, we might want to modify it a little bit more. But overall, this should work just fine. So let's go ahead and actually try this out inside of a Jupyter Notebook. Now, opening up a new Jupyter Notebook, which I just called app1 proxy generate image. I also want to go ahead and run my FastAPI dev and main.py. This, of course, will allow me to have this URL right here. So basically, we want to bring in our endpoint, and we're going to set it equal to basically that, and then slash the generate endpoint that we have in main.py. Great. So this is what we want to test out. So the way we want to do this, of course, is by using either Python requests or HTTPX. Both of them use basically the exact same calls or functions inside of the module themselves. So there we go. We've got our endpoint here. We'll go ahead and declare it as a Python function here, and we'll do our request and a response, which is going to be httpx.get then this endpoint, actually it's not get. Again, if we go back into main.py, we see that it's a post request. That's the only way it handles it. So this should be a post call. And we can also pass in something for JSON itself, which is going to be the data we want. I'm going to start out with not the prompt, and I'll go ahead and say something else. And then we're going to go ahead and run this request, and I'll do res.status code, and we're going to see what that is. 422. I can also do res.json to see what the response is. Now, of course, right out of the gates, we see that, well, you need to use the field of prompt, right? And that, of course, comes back into the schema we generated here. If I called this anything else, that would be what it's looking for in the actual request itself. So we just need to change the key for the JSON to simply the prompt itself. Now I'm going to go ahead and run it again. This time it gives a 500. The detail on this one is saying talk was not included. Where did that come from? Well, going back into our helper function, there we go. We are now seeing that the trigger word needs to be included. So if we grab a pre-existing prompt that we already have with that trigger word into our app request itself, I can now bring it in here and bring in the prompt altogether and run this again. And now what we should get is the prompt working with the ID altogether. So this is fantastic, but this should help show us why we need to lock down our requests themselves. So right out of the gates, I could accidentally run that cell 1,000 times, and that's going to end up costing me quite a bit. So there's a few different ways on how we can think about doing this. Number one, we could actually cache the prompt itself. So we could bring this prompt into cache and ensure that we're not calling it multiple times. That might be one way to do it. But the very first way, the main way that we want to do this, is we actually want to lock this down by bringing in a API rate limiting service. We want to do this right away, or as soon as possible that we can. The reason I want to do it right away is so that we're not calling this API too many times. We can lock down the parameters as to how many times we want to call it, even if it's for ourselves, especially when it comes to generating any sort of AI response. If you talk about generating AI responses, there's a good chance that the cost per response might go down over time, but right now it's still very high in relation to the cost per response to something like a database. That cost is like practically zero, whereas generating an image is not practically zero. Now at this point, we have an API endpoint that can generate images based off of our own data. It's super cool, but potentially really expensive. So what we need to do now is implement something called rate limiting. All that means is we can only request any given API endpoint a certain number of times in a certain duration. So in order for this to happen, what we need to do is we need to use a third-party package called FastAPI limiter. FastAPI itself doesn't have the mechanisms for rate limiting. We use third-party packages to make that happen. Now, in addition to this third-party package, we need a data store that's very fast and super easy to use, which of course is why we're using Upstash and Upstash Redis. So Redis itself is an in-memory data storage solution. Upstash gives it in a serverless way, which means we only pay for what we use, and they have a generous free tier, as you'll see. Now, yes, I did partner with them on this course, but their tool for Redis is fantastic. It's incredibly fast. So be sure to sign up for Upstash if you haven't already, and you're going to go ahead and log in. It's going to look something like this. Go ahead and create your database right now, and I'm going to call this SuperMe API, and we'll select the region nearest you physically or wherever you're going to deploy it. In my case, Oregon's pretty close to me, so I'm going to go ahead and say next. Notice this free. Daily command limit is 10,000. That is a lot for nothing. You don't pay a dime for it, and it's already secure, which is super cool. So go into that and then you want to grab the connection string for your database itself. So you can copy this whole thing if you want, and we want to open up .env here and paste it in, and then I'm going to go ahead and declare the key value as Redis URL. One key important part is we want to add in an S, so it's Redis secure. That is something you need to do right at the beginning for what we're going to be implementing here. Now, this isn't always going to be true. In some cases, it's not going to be true where you need to have the S in there as well, but the way we configure the rate limiter that we're going to use will need that. So with that in mind, we're going to go ahead and come into our project here, and we're going to go ahead and bring in from decouple, we're going to import the config, and we're going to go ahead and bring in our Redis URL from config of that Redis URL. Now, I actually want to have a default value in here in some sense, but the thing is I want it to error out. Just like we've talked about before, if I don't have a default value, this will have an error in here. Now, at this point, I actually have my server still running, my FastAPI dev server with that command right there. So feel free to have yours running as well. I'm pretty sure if you change .env, it does refresh the app. And if it doesn't, just go ahead and refresh the app anyway. But now we've got this Redis URL we want to implement. So how do we go about doing this? Well, at the basic level, what I'm going to do is jump into requirements.txt, and I'm going to bring in FastAPI and then dash limiter. Now, there are other packages out there that are pretty nice, and one of them is the Slow API, I believe it's called. So those two are nice packages, and I'm sure there will be more in the future. But the reason I like FastAPI limiter is how I can customize each input and just change it really, really quickly. So on my create image endpoint, I can change it, and also my homepage, I can change it so they can have different dependencies, different rate limits per endpoint, which is exactly why I am using the FastAPI limiter. Now, if you want to get a little bit more advanced, you can always check out my Try Lane Change series, where I actually customize and create a rate limiter from scratch, also using Upstash Redis to make all that happen. But the idea now is we want to bring in the FastAPI limiter and make this work. So jumping back into main.py, I want to do a few imports. The very first import is going to be from our context lib. So we'll go ahead and do from context lib. We're going to import the async context manager. What this is going to allow us to do is to define a life cycle or a lifespan function for FastAPI. So we're going to go ahead and do async def and its life and span. And then we'll just go ahead and declare this as a FastAPI application, which we really don't need to put much in here, but I'm going to leave it in because that's what the documentation recommends. Now, this is going to be our context async context manager, and I'll go ahead and say pass for the moment, and this is what we're going to do, just like that. So the idea here is we first want to connect to Redis. So the way we connect to Redis is by using the async.io version of Redis. So we're going to import redis.async.io as Redis. This is a dependency for the FastAPI limiter. So if for some reason you don't have that installed, go ahead and run that installation, or you can always run in and do the pip install -r and all of that in the root of your project. Great. So now that we've got this, what I want to do is bring in that connection in here into my lifespan. The way that's going to work is, of course, saying Redis connection, and that's going to be equal to redis.fromURL, and then we're going to go ahead and pass in our connection string here, just like that. Now, sometimes you'll need to actually bring in the encoding as well, like how you want to encode it, like UTF-8 and all of the other encoding options out there, but I think you can leave that out if you don't need to bring in the encoding. So we'll try it without it. So there is our Redis connection. Now, we could use this on any other package. And this isn't the only way you can implement this either. You can also do something called a middleware, but I'm going to do it in this one. And so what we want to do then is we want to bring in our FastAPI limiter now, which is going to go ahead and do from FastAPI_limiter. We're going to import the FastAPI limiter class, and we're going to bring it in here. We're going to go ahead and do await FastAPI limiter.init, and we're going to pass in our Redis connection. Then we're going to do something called yield, and then after that's all said and done, we're going to go ahead and await to close this out when it's all done. So it closes the connection and the rate limiter itself. So this is the default configuration. To implement this now, all we need to do is use the rate limiter itself. This means that I'm going to go ahead and do from FastAPI, and we'll go ahead and do FastAPI limiter.depends. We're going to import the rate limiter class here. inside of FastAPI itself, we are also going to go ahead and bring in depends. Let's go ahead and make sure that we bring in those parentheses in the right spot. And I'm going to bring in depends in here as well. So now we've got our rate limiter that we can use as well as depends. So if we look inside of the documentation, we're basically at the part of this right here. So we can bring in the dependencies for the rate limiter itself. So depends is going to be on the rate limiter. So inside of our home page, we're going to do it on our first one. We're going to bring in our dependencies, and there's going to be a list of dependencies, which might indicate to you that you can actually have more than one rate limiter on here, which you totally can. So in this case, I'm going to go ahead and do times, and we'll do 2, and we'll go ahead and say seconds being 5. That means I can do this request 2 times in 5 seconds. We could also update this and do something like 4 times in 10 seconds. Of course, that's basically the same thing, so it really didn't change that much. But what if I did 4 times in 20 seconds, right? So now I have 2 different rate limits that are going on. Now, there are other arguments you can do in here. You can do minutes, you can do hours, right? So I think seconds is the most granular, maybe microseconds, but we'll just do seconds for now, and we'll go ahead and give this a run. So what I want to do is I want to duplicate the notebook that I had before, and now I'm going to go ahead and do 2, and we're going to call this something like, test our, let's go ahead and get rid of that, and we'll go ahead and test API rate limit. There we go. So now I'm going to go ahead and use the endpoint for the home page, get rid of the generate one, and now we're going to go ahead and do a get request, and I'll get rid of the prompt in here as well. In fact, I'll go ahead and just bring everything on one cell because we can rerun it over and over then. Great. So here we go. So let's give this a shot, give it a quick run, and we get hello world. Do it again, hello world. Do it again. Now we get too many requests. It is now rate limited. Great. That's all we really need to do. But of course, we can modify this a little bit more. But before I modify it, I want to actually bring this down into my generate API as well. This is where you're going to be like, okay, well, how many things do I want to generate here? How often do I want to let anyone generate something in terms of the rate limit? I think 2 every 5 seconds is probably reasonable. Maybe 10 every minute, right? That might even be too much. I don't know. You can test it out as you see fit. And this should actually be minutes, of course, not minute. So you want to make it duplicated, otherwise you'll get an error. So of course you can test this out as many times as you like now on either one, including the other notebook. It will now rate limit how things are working. So all I want to do here is improve how I might be using this rate limiter, as in customizing some of the things about it. Let's take a look. When you get the API rate limit, the response is going to look like this. And there's also even a header to tell you when to retry after. So what we want to look at is another way on how we can do this, as well as something called an identifier. I just want to show you these things so you can modify them as you see fit inside of the FastAPI limiter. So first and foremost, we need a couple imports here, which is going to be the request and the response classes from FastAPI. We're also going to go ahead and from math, we're going to import the ceiling function to round up basically. And the idea being is we have 2 other functions we're going to bring in right above the lifespan here. So the default value for the rate limit handler is this. It's got the HTTP exception with that status code and that too many requests or whatever you end up putting there, and then the number to retry. That's exactly it. So you can modify this as you see fit. The other one is going to be the rate limit identifier. Right now it's attempting to use the IP address as a way to identify who's doing the request or where the request is coming from. This might be something you want to change to being based off of an API or an API user. We'll see this in a little bit. But for now, what you would do to actually implement those things is you first off do your identifier. You pass that in for this rate limit identifier. And then you can also pass in the HTTP callback, which is going to be this right here, which takes in all of those arguments. And that's exactly how we can modify these things. Now, to verify this, we can just say, for instance, too many requests, try again soon. something like that. Just a simple modification just to make sure that it is working. And so back into our tests, we can run this again, and we can eventually see too many requests, try again soon. Great, that part is actually showing us the difference. Now the actual identifier itself is going to be stored inside of Redis 2. So if you go into Redis into the data browser and just do a quick refresh in there, you will see the IP address that it's attempting to store in here. So if we wanted to just change it to a user, let's go ahead and change it to 1. Right? I'll just change it to the string of 1 as if it was the username itself, and just making sure that everything is still running. I'm going to go ahead and just duplicate this again. And there we go, too many requests. Now what we should see is that right there. So there is other data based off of the actual API endpoint itself, and also the different depends that we have in here. So we've got a couple different depends in here, and that's actually keeping track of all of that for us. But it's also showing us the identifiers in there with those other depends or those rate limits for that API endpoint. Now, of course, you'll probably want to keep in the path in there as well. So, for example, if you wanted to bring in that path, it would be something along those lines, maybe path, or let's say user, and then 1, and then that path, something along those lines. Let's go ahead and see what that looks like with our request now. I'll go ahead and do this a few times. There we go. If I refresh in here, you can now see that it has user, the ID, then the path, and then the other rate limit stuff. Pretty cool. So being able to modify these things is really important, and I just want to give you a very simple example of it using the FastAPI limiter. Again, this package does this uniquely in this way. There's many other ways on how you can consider doing it, but for now we're going to leave it at this. Now, of course, what we want to do is, the reason I alluded to a user in the first place is to actually have something like that, actually have a user showing up with an API key, because rate limiting is great, but it's even better if we have some sort of API key that prevents a request if they're not valid anyway, so that we have a little bit more security in our system so that we're not accidentally racking up those bills for no reason. Even though this is meant to be a microservice, it's always a good idea to further require some sort of authentication and authorization to any given API endpoint. Now, the way we're going to do this is by having a specific header for our API key and a specific API key. So the way I'm going to generate the API key is opening up my terminal here. I'm going to go ahead and do Python 3-C, and we're going to go ahead and do import secrets, and then we're going to go ahead and print out secrets.token_URL safe, and then however long you want to make it, I'll just do it as 32 characters. There's the actual token I'll end up using. So the way this is going to work is in my .env, I'm going to come in here and I'm going to go ahead and give it my API access key, and we're going to set it equal to that value. So as soon as I have this API access key, I can start testing this out. So this means in my API tests here, I can now come in and do headers equals to, well, what is the header going to end up being? In our case, we want to create a new one called X API and key, and we want to go ahead and pass in that access key itself. So inside of the notebook again, we'll go ahead and do from decouple. We're going to go ahead and import config, and then we'll go ahead and set the value for that one based off of the environment variables. Great. So this, of course, is going to go to the request. Now, if we want it working on the API itself, I want to have that same API access key value. And so I'm going to go ahead and bring this in just like that. I'm also going to go ahead and bring in my API key header, and it's just going to be x-api-key. This also could be an environment variable if you want to make it one. I'm actually not going to. I'm just going to work based off of that single header, and then it will be useful in any place that I need to. Okay, so now that I've got these things, I want to build out something called a custom middleware. So middleware itself happens in between requests, in between somebody requesting an endpoint and responding back. It happens in between both things, in between the request and in between the response. So I'm going to go ahead and now do right here, do app.middleware, and it's going to be HTTP middleware, and it's going to be an async def, and we'll do custom API key middleware, and it takes in a request, and it takes in a response, or rather call next. Okay, And that call next is going to be the response. So we'll just do await and call next of the request, and then returns back the response. As it stands right now, this is exactly the same thing as it was. So what I can do here is I can actually print out the request.headers.get of that API key, whatever that ends up being, like that. Okay, and so one of my notebooks has these keys. I just need to make sure that I'm passing the headers when I do the requests then. So now I'm going to go ahead and run this. This may or may not end up working. The API access key is not currently found in my .env, so I might have to restart my notebook itself and see if that solves that problem. Looks like it does. It does that hello world. What I should see though is a print statement in Python for that key. There it is. So we can now see that the key is actually working, or at least the header is working, it's bringing in there. So all we really want to do is we want to verify that it's the same. So basically this is going to be my request key header, and it's going to be that. Now I just want to go ahead and say if the string of that, which it should be a string, but it also might be none. I just want to check that it is equal to the actual API access key, the one in my environment variables. And more specifically, if it's not equal to that, then we're going to return something a little bit different here. We could always raise an exception like we saw before, which was this up here. Or what I can do is I can return back a JSON response just so the data is a little bit more clear, or we can return back the response as we see fit. So I'm going to go ahead and do FastAPI.responses. We're going to import the JSON response to send back JSON data. So going back into the middleware there, that's what we'll return if that is incorrect. And we'll give a status code of 403. And then I'll just go ahead and pass in some content with the detail saying that it's an invalid key, try again, or unauthorized access or something like that. But since it's a microservice, using invalid key is probably fine. Okay, so now what we're going to do is we're going to try this out with an invalid key. So to do that, I'm just going to go ahead and bring in a different header here. I'm going to go ahead and run this, and there we go. Invalid key, try again. Now if I put the key in, it works. And it works in conjunction with the API requests as well. I'm now going to get rid of that print statement, and there is our custom middleware that allows for this API key. Now, one thing I will say, if you want to have a global rate limiter and you want to do it directly with Redis and not having any third-party packages on here like FastAPI Limiter, I actually go through that in my Try LangChain course, but you could always go into the code itself and you can see exactly how I make it happen with the actual key that's stored in Redis, and then actually going through and implementing rate limiting that way. That is certainly another way you can do it. The reason I didn't go that way in this one has everything to do with the fact that I want to have specific rate limits for this very specific endpoint. And I think the FastAPI limiter is one you'll probably use more often than customizing your own solution altogether. To make our project a little bit more maintainable, I actually want to move all the rate limit stuff out of main.py and move it into our helpers for rate limiting.py, something along those lines. Then we're going to go ahead and come in here and basically grab lifespan and up. So I'm going to go ahead and copy all this stuff, bring it into rate limiting, and we'll get rid of the things that we just simply don't need in here that are grayed out thanks to VS Code. So once we have all of that all set up, then we will come back and import this into where it needs to go. So one of the things, of course, I probably don't need are the API key and API access key stuff. We can get rid of that. The main thing is the lifespan itself. So that's what I actually want to be able to bring in. And it still needs the FastAPI class itself because that's how it ends up working. Great. So now that I've got this, I'm going to go ahead and come into main. And then I'll just go ahead and do, from helpers.rate limiting import lifespan. And then just put that down here. It's already in there. I'm going to go ahead and say something like lifespan as my rate limit lifespan or something along those lines, just so it's very clear as to what is going on with that. And now I can get rid of the rate limit stuff that's right in line, with maybe the exception of this import because we still will need that. But this is just mostly meant to clean up this single function here so we don't have everything inside of main.py, but hopefully it should still work. Now the actual middleware itself, this is maybe something else I would want to bring elsewhere, but I'm going to leave it in just like that to work just as it was. But now if we look in here, I'm just going to do a quick API test just to make sure hello world's going through. If I do the other app, the generate one, I should actually get an error from this because I don't have the API key now. That is great. That is also working. But now that we've got this rate limiting, helper, function, and module, what we want to do now is we want to start the process of actually returning back some of the results from generating any of our images. So let's take a look at how we do that now. Now we need a way to list out the results from our asynchronous or our background generation. This is fairly straightforward with the replicate client, but there's a few things we need to consider to make sure that it's working with our API. So the first thing that I want to do is I'm going to go ahead and grab just this generation of replicate client and all that, basically as a starting point. And what I want to call this is we'll go ahead and say something like list pred or prediction results. Okay. And so the idea with this is it's actually really simple. If we just went the simple route of it, the predictions would be from that client .predictions.list. And then we could return that as the value itself. Unfortunately and fortunately with this, it actually doesn't go based off of the model or model version. It goes based off of your client. It goes based off of your account. So of course we want to narrow it down based off of the model and model version. There's a lot of different ways in how we can think about doing that. What I want to do is say model and actually grab that, and then also version and actually grab that. So when I do list out these results, I can change the versions as we see fit. Do keep in mind, these prediction results, I don't think they will persist for very long. So they actually do get deleted away. Maybe certain accounts don't do that, but overall, these won't really persist that long. So it's much more of a short-term ability to grab results. These are more like recent prediction results is the way I think about it. It probably has some things about long-term ones, but what it doesn't have is the long-term file output. So this is something we would want to do fairly early on. So the idea then is we've got these prediction results. This gives us our predictions. So what we actually want though is the results themselves, which actually comes from, let's go ahead and do the list of the predictions.results. Let's take a look at what this looks like in the API itself before we start narrowing it down to the model and model version. So the way we're going to do this is the same way as we did generate image, as in bring out list predictions here or list prediction results and bring this in as the helper functions. Now in main.py, we're going to go ahead and create a new API, which is going to be largely based off of Git. And we'll come down here. And this, of course, is going to be now, let's call it just simply predictions. The rate limiter, to me, doesn't matter so much. Of course, we don't want to overload our system, but we can do something like 100 times every 20 seconds. That's probably plenty, maybe even 1,000 times. That's fine. Great. So with this in mind, we're now going to go ahead and come in here and say results equals to helpers dot, list prediction results, just like that. And then we'll go ahead and return this back. We do need to rename the function here. We're going to call this something like list prediction results. Actually, that is conflicting, so we're going to go ahead and just call this list prediction result view, or list predictions view, something like that. Great. So with this in mind, let's go back into testing this API here, and I'm just going to go ahead and copy a lot of the things we've already done. Really, all I need is the endpoint and the API access header, so we'll go ahead and bring it in here. And this time is going to be, well, let's go ahead and make sure we grab the correct endpoint itself, just like that. And let's go ahead and run a couple cells here. And there we go. So here's our prediction results. So what we see is the model and the version, right? And we also don't see the URL as to where I can get more information. In fact, I'm probably getting too much information in here. I don't necessarily need all of this. So I do want to narrow it down. Now, of course, you could keep all of this, but one of the things that we are trying to do with our API is to make it more simple for us so we don't have to think about, oh, do I need to do these URLs or something different? So what I want to do is two things. That is going to be, we're going to change the results a little bit of our actual endpoint, not in the endpoint itself, but rather in the helper function itself. So inside of here, we're going to want to change this a little bit. So we're going to go ahead and say results equals to the list of these results. So if I just did x for x in results, this is the same thing. But what I can also do in here is do a dictionary. So I can actually turn it into a dictionary in there as well. This is something that the replicate has that you would just need to experiment with on your own. And of course, you can always rerun the API request to see if that's true, if that even works in there. So that's pretty cool. So this is now a Python dictionary. But what I can also do is I can say if x.model equals to the model that's being passed, which right now it's the default one from the environment variables. So you might want to have this in the function, you might not. It's really going to be up to you on how you think about that. So now if we save it, the exact same results should come back because I'm only using one model at this time, right? So they're the same results overall. The next thing is, of course, the actual version. So this might be something you've already changed. So going back in here, we can also say and x.version equals to the version. Great. So now we're getting a little bit closer to what we want from the results themselves. Now I'm actually going to leave just simply x in here for a reason because I'm going to iterate through this again. And what I'm going to do here is I'm going to change it a little bit, change the actual dictionary that's coming through. And the way I'm going to change it is going to be the URL itself, which is going to be a new URL that we don't have yet, which we're going to go ahead and say predictions and x.id. Then I'm also going to bring in maybe like status and x.status and maybe the created one, something like created and x.created, right? So we could absolutely do this. The reason I can use dot notation has to do with the replicate client. If you did change it into a dictionary here, then you would have to use dictionary lookups, right? So actually using the position lookups where it'd be something a little bit more like that if you were using the dictionary. But since I'm not using the dictionary just yet, I am actually just creating a brand new one in here. So we can go ahead and save this and run the API again. And now we should see different results. So if I run this through, unless of course I have an error, which in this case I do have an error. So let's go ahead and see what that error might be. Perhaps it's something with the actual dictionary itself. Let's take a look. Here is the dictionary we are creating from it. And we want to make sure that we're doing everything correct within the dictionary, but maybe it's not correct yet. So I'm going to go ahead and comment that one out and see what's going on here with the result. And it looks like that one ended up working. So it's certainly something with this part right here with the results coming back. So we've got x.created, and I think maybe it's a key value problem. So let's try created at and take a look inside of here. We've got completed at, which might be another one we want to use. There it is. It's created at. It's not dot created. That was the problem. Okay, great. So now that we've got that, of course, you would figure that out by inspecting all of the key value pairs that are in there. But now this is a lot more narrow as to what's going on with it, right? And so if we wanted to enrich this a little bit, we can also do completed at, right? So let's go ahead and enrich it with completed at. And of course, that will not be a value if it's not actually created. Let's go ahead and run this again. And we can see the created at and completed at. Now, I'm actually pretty sure the most recent one is going to be first. This is the order of things. Now, unfortunately and fortunately, the actual API itself, this right here, doesn't really have the ability to sort these things or narrow them. We kind of have to do that ourselves, which is exactly why I'm showing you this. Now, another thing about this data right here, or even the results in general, is you might consider building this out where it's Pydantic, actually doing a different schema. This could certainly be improved quite a bit, but I'm going to leave it like that because it's only a few fields. One thing I will do is I'm not going to iterate through it twice. I just did that to show you this if condition in here, and I can just put that down here now. So it's one big, list condition in here like that. Now, one of the reasons I have this results here is for the next part of pagination. So we can come in here and say something like max size, and I'll go and say 500. Now, right now, I don't actually have that many results. I don't need pagination, but if you were to look at the API, let's go ahead and just return back the list itself. So let's return back preds and then run the API again. What we should see in here assuming that everything was saved, let's go ahead and do preds.next, and we'll do preds.results, something like that, and see if that solves the API problem. We might have to print it out, but there we go. So we've got pred.next being none, and then the results coming through. So what happens is there is pagination, but I think at maximum it will do 100 results coming through here. That's why I have this max size, basically saying if, or we'll go ahead and say while preds.next, then we're going to go ahead and create new results, which really means that we'll go ahead and do underscore preds equals to just another lookup, but now we can actually pass in preds.next into that, which gives us the next value that would come through. And then once again, we do the results, but this time we would just go ahead and do plus equals to what those results are. And then we would just check if the length of those results is greater than the max size, then we're going to go ahead and break that while loop. And that's how we can actually iterate through based off of a certain number. Now, of course, there are other ways to do pagination. This is just a simple way, or a way that I think is fairly effective to get a certain number that's coming through in there. In our case, we actually won't have more than however many, 30, 40, 50 at any given time. And realistically, I don't think you'll need to have this max size. In the long run, I would actually want to store these predictions into a database like a SQL database so that I can look back and take a look at them and not really go this method itself. But that's not something I'm going to do right now because I'm not actually trying to solve that problem. What I'm trying to solve here is to be able to get the outputs themselves, directly those outputs. But at this time, we now have an endpoint, an API endpoint, that allows us to at least see what's going on with our predictions. So if we go through and generate a new response, 2 responses right there, and then take a look at our API results here, what we should see is we should see results that are coming through in here. And let's go ahead and take a look at our API. It looks like we've got no results coming through yet, so let's go ahead and see what's going on here. Oh, I got an invalid API key. What do you know? My API is working. So let's go ahead and make sure we bring that into our generation now that we've got it. And let's actually do a generation inside of our project now. So headers and headers. There we go. Oops, looks like I didn't start at the right cell here. What's going on? Headers. And we're getting a problem with the API access key, so I need to restart everything. And here we go. There we are. And now I've got a result going. There we go. Now I can test that result or see that it is in my list, and most likely it's going to be the most recent one. Sure enough, it is. So this also means to me that maybe I only need the first few, or I need to adjust this even further and allow for statuses in here. So in other words, if we go back into our client, I'm now going to go ahead and just do status equals to none and basically say this now is going to be our results. That's what it currently is. I'll go ahead and say if status is not none, then we're going to go ahead and narrow this down again, or basically do the same thing. So I'm going to go ahead and copy this and say an else clause, do our results like that. This is quite a list comprehension itself. Otherwise, the status itself will go ahead and say and x.status equals to status. By default, the none works. You could also do succeeded in there if you wanted to, but what this means is then we would jump back into our API endpoint here, and we would need to add in an optional value here, which is going to be status optional of an str, otherwise it's none. Then we can pass this in as an argument here, and inside of typing, we need to bring optional in there, so we'll go ahead and do that now. So from typing, import optional. There we go. So then we've got an optional string in here. So back into our test now, I can pass in some data here and do something like params equals to, then we bring in status being, let's say processing. Just another way to do a lookup. And this error right here isn't telling me a whole lot. So if I actually take a look at the FastAPI error, I see that I've got a dictionary object does not have attribute model. So this, of course, means that there's something with the replicate API part, and it has to do with this right here. So I actually don't love this, so I'm going to go ahead and get rid of it altogether, and we will now narrow down the already changed results and basically say something along these lines. We'll go ahead and say for results in, and I'll just go ahead and use X there. Now I can see what the problem is. We can say if X equals the status, right? So this is actually now dictionary data. So I need to use that dictionary lookup. This I think is a little bit cleaner overall. So let's go ahead and save that, and let's refresh in here, run it again. Now we can see that there's none processing. So that happened because it took a little too long to figure out what was going on with it. But now if I run it again to process again, I should be able to see what's processing, and there we go. So this is a cool thing as well. Now, of course, we could do this on our predictions, or I could just make another endpoint called processing and passing in processing as the status, and just get rid of this here, and we'll do list processing view. And I believe that was the API endpoint, or the actual status value, one of the status values that could be. Of course, you could always look up the status values inside of the replicate documentation, but now we have a way to list things down and narrow them a little bit. Now, again, I don't necessarily love this status process right here, or the result process. There are ways to improve this for sure, but I'm just trying to get a working model so that we can actually get the result that we're looking for, which is, hey, is this still processing, or is it done? And then, hey, if it is done, can I download the image now? Now we need to build out the detail view for any given prediction. This detail view will have the replicate response in it as a core part of what's going on. So let's go ahead and take a look at how we're going to do that. First and foremost, jump into replicate itself. We're going to go ahead and grab the list predictions itself in here, and then we're going to come back down and do something a little bit different. This time is going to be pred, and then it'll just be .get, and what we want in here is going to be the prediction ID, and we'll go ahead and say none to start, but we'll go ahead and bring this in just like that. And to start out, I'm going to return back that prediction itself. So this is, of course, going to be now get our prediction detail, something along those lines. The model and version, I probably don't need to show up right now. I could keep that in there and cause errors if it's the incorrect model or the incorrect version, but I'm going to leave it in where I can just grab any detail view as I see fit. So with this in mind, I'm going to go ahead and bring it into my helpers. And once again, we'll go ahead and bring it in here. Very similar to what we've already seen with these other ones, with the imports themselves into parentheses now. So we have multiple lists in here, just a little bit more organized. And there we go. Back into our main.py, I'm going to go ahead and copy the predictions list part here. Now it's going to be get prediction view or prediction detail view, something like that. We'll call it prediction detail view. And this is going to be predictions. And then we're going to go ahead and bring in the prediction ID as a string just like that. And this should be an underscore. Now, this is, of course, so we can actually grab this argument coming in as an argument. Now, by default, it is a string. That is the ID data type according to replicate. So in here, then, we are going to go ahead and do our get prediction detail with that ID coming through, and that's it. So with this in mind, I'm going to go back into my test API here, and once again, copying all of my API access stuff. I'm going to paste this in. The new endpoint is going to be one of these. It pretty much can be any of them. You might want to have the recent one in here as well. So I'm actually going to go ahead and sort of automate that itself. So I'm going to go ahead and say pred's response equals to this. And then in here, we will get our pred's response, which is going to be our pred's JSON, which is this right here. I don't really need to show all of those other things any longer, but there's our pred JSON. So basically what I want to do is I want to be able to grab that most recent one's URL. So we'll go ahead and say our detail URL is going to be equal to something like that. And that is the URL endpoint we are going to look up. That's exactly why I created it in that way, so that I could use it for those endpoints. Now do keep in mind, this is actually the URL path, so it's not quite the URL. So we can just bring in the string in here like this, And there we go. And let's just go ahead and make this a little bit better and say our recent URL equals to our recent prediction URL, and maybe like that. And if not starts with the slash, then we'll go ahead and return, and then we'll change it to have that slash. Of course, we have that, but maybe you forgot to do it. So there we go. Okay, so now we've got this detail URL. This time I'm just going to go ahead and return back response JSON, run that, and there we go. So here we now have a bunch of detail. So once again, maybe we want all this detail, maybe not. So these outputs right here, these are most likely the correct outputs. Now do keep in mind, there is a index value on here, which I think is actually really important. So it does say out 0, out 1. So I think we can actually use that to our advantage when we actually do want to display those things. But let's go ahead and do something where maybe the actual URL itself is incorrect. Let's go ahead and do something like this, and I'll just go ahead and comment out the recent one. We run that. Now we get a little bit of an error in here. So we've got the response being incorrect. So we'll do response.status code in here, and I'll comment that part out for a moment. I get a 500 error. So if we look at that error itself, we see that we get an exception from replicate itself. This is where we actually probably want to bring in this exception altogether. So I'm now going to grab this and jump into replicate, and we'll go ahead and do from, replicate.exceptions. We're going to import the replicate error. Okay. And so I'm not sure if that's going to be always the 404 error, but that's how I'm going to go ahead and handle it. So I'm going to go ahead and say try and then accept replicate error. We're going to return back none and 404. This is going to return back pred and 200. Otherwise, we're going to now change this to being accept and return back none and 500. Now, this is the process that I'm doing mostly so I can handle it in the front end a little bit differently than I currently am. This might be something I want to do in generate as well. Instead of having an exception here, actually return back what I want with the actual status code itself. So I'm basically just saying if replicate has an error, I'm just going to go ahead and say that's a 400 error. There's a good chance that I would want to expand on this a little bit, but for now I'm just going to leave it as is. So now we're going to go ahead and get this detail view. The result, probably should just be result and then status, right? And basically in here, result and status. Now we're going to go ahead and say if status equals to 404 equals 404, then we're going to go ahead and do the 404 exception, which is similar to this, but I'm going to just change it a little bit where it's this right here. And we'll go ahead and say, pred not found, prediction not found. And then, of course, the other one being else if status equals to 500, then we can do the 500 version and say something like, well, we can actually even pass that status code in here, and we'll go ahead and say server error, right? Great. So 2 ways on how we can handle those exceptions. This is a very important one for the detail if you make a mistake there. The predictions list is likely not going to be a mistake that would happen itself. But now that we've got this in here, if I run this, now I get a 404 instead of a 500 error, which of course that's what I should get. And now if I look at the actual value itself, I should no longer get that error. And of course, if I get rid of that prediction slash, there's my 200, and I'm now actually working in a good spot. Now we're going to take a look at the output index pattern. This means that any given prediction has a certain number of outputs that may be available to us. We need to see what that pattern is so that we can know which URL to generate for it. So let's take a look at what this does by going into the same notebook where we actually had some data coming through. I get this key error here. If I scroll up a little bit, it's probably because I have made some changes with my responses here. So there is our new response with all of that data. So I probably won't have that key error anymore. So if I run it again, there's my 200. And of course, if I actually take a look at the detailed data, there's that detailed data. Now, the point of this is I actually want to iterate through all of my list of predictions, or at least some of them, to get out the detailed data for each one so I can really start to understand the output itself. So the way this is going to work is we're going to go ahead and say something like for obj in the preds JSON, and we'll print out obj. And of course, this is going to give me all of that list view data in here, which means that I can actually use my obj path, which is going to be equal to the data itself for that URL. Or to simplify things, I'll just go ahead and say path. Then our endpoint is going to be based off of that path, very similar to what we've already seen with this detail URL right here. I'm actually going to not call it detail URL, but just call it endpoint, because that's how I tend to term things. Now, I definitely have that, path, the actual preceding slash on there, so I don't need to redo that at all. In fact, I don't need to redo a whole lot in here. I'm just going to go ahead and say the response is going to be equal to that endpoint with those same headers. And I'll go ahead and say if res.statuscode not in range 200, 299, I'll just go ahead and hit continue. Great. So the actual data then is going to be res.json, and then we can actually take a look at the detailed data itself, which in my case, I actually don't want to go through every response here. I'm going to go ahead and do something like, 20 of them, and then I'll just go through that iteration. And so what we see here is, of course, that data. The problem, though, is I see the data as a list. Going back into main.py, if we look at the detail, I see that I'm actually returning 2 objects in here. I want to just return 1. I don't need to return the status code in there. That was certainly a typo. So now we go in through this again, and now we can see that we're getting all of the detailed data that's coming through on any given item. So that also means that then in here, I'm going to go ahead and the ID, I'll go ahead and grab that. I'm going to go ahead and grab the inputs, which I'll go ahead and put as an underscore as well, because input itself is a reserved keyword. And then I'll go ahead and do the same thing with output, just because I did it with the other 2, not because I need to. But there we go. So we've got ID, we'll do ID, input, and output. We run this, and now what we should see is, well, our input and output for some of these is simply none. This, of course, is because Replicate's not necessarily going to store all of this data. That's important to us because if we want to rely on an API, we will want to have some of these data being stored. So if we were going to offer this as a service to somebody, we would want to make sure that we are storing the output data long term. Replicate might have a plan to do that. I just don't have that plan. So at this time, I'm going to go ahead and actually do something that is fairly straightforward, which is if output is none, then we would just go ahead and hit continue, in which case it's going to narrow down our results here quite a bit. Great. So the idea, though, is I actually don't really need that much of the input data. The main thing I need is the number of outputs, the expected number of outputs that we have in here. We could absolutely grab the prompt and the output format and all of the other things that we might have put in as the input. These other ones were those defaults that we just ran with. The newer ones don't have all those defaults, which is kind of cool that we can go back in time and see what those inputs are. Granted, we have these inputs when we did the request itself. So there's another option that we can store data, is all of the inputs that are going into any given request. But in our case, we're going to go ahead and just grab the output itself, or the number of outputs. And this is going to be just simply from input data.get and those number of outputs. So that means that in here, I'm just going to go ahead and say or an empty dictionary, which means that number of outputs could be either a number, or we'll go ahead and give it a 0, right? So now I can just come in and just have my number of outputs, and there we go. Okay, great. So the number of outputs then is going to be directly correlated to the outputs themselves. So what I want to do now is actually want to see those outputs. Let's just go ahead and take a look at the print statement down here. Here's this long URL here. Now, one of the things I want to do with my API is I don't want to share this URL, especially if I move from Replicate to something different, right? So if I were to build out a different, AI generated model service, I want to make sure that my API can adjust to that. The way it's going to adjust is by having my own detail view for those individual images, for those actual outputs. So that means then is I want to actually grab the names of them so I can see what the index pattern is. Now, just by looking at the images, you can probably already guess what the index pattern is, but let's go ahead and just take a look. And I'll go ahead and say output, I'll call it output names, and we're going to go ahead and do X for X in output. Now, one of the things that's really cool about pathlib is we can actually use it here. So if I do import pathlib and then I just run, something like pathlib.path, I can grab that URL and I can do .name, and this will give me a list of names. And there we go. So what we're seeing with this list is there is an index value in here, which actually tells me that based off of the number of inputs, I know that there's a certain number of outputs that are coming through. Those outputs are in a specific position, right? So if you think about the list itself, the one with the 0 in it is at the 0 index. The one with the 1 in it is at the 1 index. Great. So that means that I have a way to do a new endpoint for this data itself. So for example, the URL that we currently have, if we take a look at that URL, let's go ahead and see that. We've got this URL here. So that means then the other valid URLs would be something like that. Let's go ahead and use it where it's like, we'll go ahead and put a string here. And then we can go ahead and say file and then the iteration that it's going to be in, right? And so let's go ahead and do for X in range, 0 to the number of outputs. Then I should be able to print out that path file X, and it actually hopefully will give us the correct one. So let's go ahead and take a look at that. And there we go. So we got 0, 1, 0, 1, 0, 0, 0, and so on, right? So that's a big part of doing this. So now we know that we can enrich our data, the actual detail view, to be slightly different. We're not going to do that yet because we wanted to uncover this pattern. Now, Replicate is one that does it this way. Not all of them are going to necessarily do it this way, but it is really nice to see that that is a way that we can have a detail view. When it comes to individual files, especially like images or videos, you definitely need to have one single endpoint for it to be able to look that thing up and download that thing. Now, the other part of this is going to be the extension itself, right? So we actually do have output names, so I don't necessarily have to do this range here. I can actually just go based off of the output names themselves, and I can enumerate it so it's similar to the range itself, right? But now I can actually bring in the name here, and we can grab the suffix. So that's going to be the, this actually is inside of the name here. So if I get rid of .name, I can just do the suffix being, let's say this is our output path. Now I can do this. Or I could just make all of those the suffix itself, and then I can just come in and grab that suffix, and then here we go. So now it's actually showing a new path that we've created based off of a previous one that's in here. Now, of course, what they did was out dash something like that, which we could also do as well. In other words, we could just use the path name. So let's go ahead and change this out from something different, and we just do output path.name, and we can now take a look at the same information. So we can handle it however we'd like. Me personally, I'm going to go ahead and do it based off of the index. I think I would prefer it based off of the index, based off of what I want to build out, basically, right? So there we go. So now we can enrich our own URLs with these paths instead of the default, replicate paths themselves. Let's take a look at how we do that, and then we'll start the streaming process of that data. Now that we have the URL path we want to use for downloading our images, we have a new conundrum. That is, do we store it in as output when we actually do the API request itself? Or do we have to implement a new method for serializing this data? Now, of course, if you looked at the title of this one, the new method is what we're going to end up doing. We actually want to limit the amount of times we modify the API request directly in our helpers. Instead, what we want is we want to use something called schemas from Pydantic, or models from Pydantic. So this means we're going to go ahead and actually generate the data we need from a class, a Python class, to do so. Now, if you're familiar with data classes, Pydantic is going to be fairly straightforward, but the idea is we want our prediction detail model, and what it's going to have is all of the fields we want to show as our API endpoint. So we'll start off with a very simple one, and that is going to be our ID. As far as Pydantic is concerned, it is a string, so we're going to stick with that. And then I'll also go ahead and do something like our model, also a string, and we're going to stick with that. So this is the data that we're going to end up wanting. We're just going to show this for a illustration purposes, which will have an ID and then a model, which of course will match our model. So that's kind of the response we'll get back here shortly as we build this thing out. So in order for this to work, we need to bring in from Pydantic, we need to import base model. I believe Pydantic is a requirement of FastAPI because it's so fundamental. But the idea is this is the structure of the data we want to have come back. We have seen something very similar to this, but I'm going to stick with just this for now. I'm going to grab this Pydantic model. We're going to go into main.py and we're going to import it. So we're going to go ahead and just do from dot import schemas, so that it grabs the schemas right there. If for some reason that's not working, we will modify it in just a moment. But the idea here is we come down, we're going to bring in to our detail view, we're going to use schemas dot the base model schema itself, and then we want to do something here. And this something we're going to do is by turning this into a dictionary response and then unpacking it like that. Right? That is one way on how we could go about doing this. I can also bring in a response model up here, which is another thing that we will need to do. And we can bring in response model and set that equal to the schemas dot prediction detail model. Great. So let's save that. Let's make sure that everything's working okay. The relative import is not working. So I'm just going to go ahead and move the schemas into the helpers as well. And it won't necessarily refactor everything, but I'm going to go ahead and do, from helpers, import schemas like that, and just use the schemas in there. Now we shouldn't have a relative import problem, and we don't. Okay, so there we go. We've got our schemas in here, and now we've got a brand new detail view that hopefully will work. When I say hopefully, let's go ahead and try it out by jumping back into our API itself, the test that we've been running, and then we're going to go ahead and print out the data for any given detail view. And what we should see is hopefully not an error, but rather the actual data itself. There's the data. We've got ID and model, and that's it. That's because of this schema. So this actually simplifies the process for us in terms of how this schema comes out. But what we actually want to do is we want to modify how we end up bringing out the model detail based off of the API endpoint that we're using. In other words, inside of my schema here, I'm going to define a class method, and we're going to call this from replicate. And this is going to take in the class as the first argument, which of course is this class here. And then we're going to go ahead and bring in the data that's coming back, and we're going to return back the class, an instance of that class based off of this data. We're going to be a little bit more deliberate with the data now. We're going to say ID equals to data.get ID, and then the model equals to data.get and model. Now, the reason I'm doing this now is because I also want to bring in a URL, which is going to be a string in here. So we grab the URL, and of course, if you remember, it's based off of the ID itself. So we can actually bring the ID up a little bit, and we'll just go ahead and call it underscore ID so it doesn't conflict with the reserved keyword. But then we can actually do our URL and say predictions / that URL. Great. So far, so good. With this in mind now, going back into main.py, instead of doing schemas this way, we would just say .from replicate and then pass in the replicate dictionary once again. We could also just pass in the replicate value itself, but I'm going to leave it in as a dictionary so that I can do additional things in terms of the typing and using data types. So from typing, we're going to go ahead and import the dictionary value, or dict, and then any, or the dict type. So the way this works is we actually declare the type with that colon, just like everything up there. Then we say the dictionary itself, which is going to have two data types. The string is going to be for the key, and then any is going to be for the value, because key value pairs in dictionaries, that is how it ends up being. Now, with this in mind, we also want it to return a specific instance. That specific instance is just going to be the string of the actual class that it's using, which is exactly what it's returning. That's important when you use data types. You need to have the inputs being a specific data type and then the outputs as well. Great. So now that we've got this, it's a little bit closer to what we want. Once again, we can test it out with the API requests, and we can see there is that URL coming through with our model as well. So expanding on this is definitely a good idea, but the cool thing about expanding on it is going to be coming directly from the replicate data itself. So we can really think about all of the different items we might want to have in here now. Now, a big part of the reason we didn't do it before is because it just wasn't that necessary before. Now it is necessary, so we bring in something like the version itself. We can bring in that version in here. We could also bring in something like the created at data. So data.get, and that's going to be created at, and all of the data points that we actually want, right? And so as soon as we want to bring it in, we need to declare it up here, which in this case, the created at will almost certainly be there. So we'll go ahead and bring in from date and time. We'll bring in the date time object, and we'll make it that type. Now, one of the other things is maybe completed at. So if you bring in completed at in here, you will actually have an optional date and time because it's not done yet. So we just say optional, like initially it's not done yet. So we just bring it in as an optional item, and there we go. And the default for it will be none. All of these are required. This one is optional now. So down in here, we can then go ahead and say completed at equals to data.get completed at or none, right? And so we can continue to build this out. The main reason I'm doing this, though, is not for the original data, although it is nice that it's now going to restrict what data is coming back. And it does it just by going into that schema. I don't have to modify anything with replicate, which of course is very important. But now it's very specific to what I want from it. It doesn't have to have all of the API data, and it's well prepared if there's another service that comes out there that we want to change. Now, I also would probably consider changing the helper function itself to just using helper._replicate get prediction detail and go based off of that. But that's going down a rabbit hole we don't need to go through yet. This schema validation is something we do need to go through and make sure that it's done correctly. So the next part of this would be something like our files, the actual file list itself, which is going to be optional. It's going to have to be a list, and we want to use the list data type class, which we import again from typing. That list is going to be a bunch of strings in there, and it's going to be a default of an empty list. So how do we grab those files? Well, we just did all of the logic for it just a little bit ago. It's all of this right here. So I'm going to go ahead and copy this, and we're going to paste it in here and open this up to see what's going on with that data. Okay, so the question, of course, is do we need the number of inputs? Maybe. I don't need this output part right here necessarily. I definitely don't need the continue itself, but the output names, these are going to be almost those file names. It's really much more this print statement that we ended up doing. So of course we need to bring in pathlib here. I always like using the entire module, but you could always do it as from pathlib import path, which is very often what you'll see in a lot of code out there. So the idea, of course, is getting the output from the data and then getting those output names, and then finally having our files being an empty list here. And this, of course, is more of like files URL. But now what we can do is we can do files.append and then appending the files that we want. So what is the actual detail path that we're using? Well, we actually have the file path right here. We actually did set it. So I'm going to go ahead and paste this up here. I don't need the detail data being twice. But now I can use that data here. We're going to go ahead and use that default URL here that doesn't have a trailing slash, file, suffix, all of that. So now we've got our file append that data. These are going to be our files then. And now we can come down here and do files equals to files, and the URL is equal to that URL. And naturally, we can also have the number of outputs if we want. So bring the number of outputs in, and this is going to be the optional value of an integer, and the default will be 0. So once again, we can bring in that as well based off of the logic that we were creating. And so now the API itself has the correct endpoints for where those files end up being. Now I'm calling them files because I've modified what the replicate data is doing to fit a little bit better with what I'm looking for. So back into our API test now, if I were to run this, I should get all of the data necessary to eventually be able to do those lookups. There's my files in there, if they even exist. And of course, in some cases, they will not exist, which is something we could look at some point as well. But that's it. We now have that data. Let's actually go ahead and see some of the outputs that don't have that data, just so we can see if the files are just an empty list in there. And in some cases, it looks like we are getting some of that data in there. I think we're probably getting some errors, and it looks like, yes, we are getting some errors with our schemas, which is why we're not getting that much data. It has to do with this output being none, or basically an empty list here. That might be the option that solves that problem for us because of the error we were getting. So let's go ahead and do that again inside of the API and just make sure that the API itself is not getting any errors. I don't have any there. Those don't seem to be coming through. But if I were to look at the data that's coming back, we can now see that some of them don't have any files. Now it's actually time to stream our file content. Now, the way this is going to work is very similar to what we have with our prediction itself, but now all we need to do is create this as files, so /files, and then maybe our index ID, right? Something along those lines. And so this is going to be now our prediction. Let's go ahead and say file output view. This takes in the prediction string and then our index ID, which should be an integer now. So naturally, we're still going to get the exact same results as we did before. From there, we need to grab the actual output itself, which is going to be fairly straightforward. It's going to grab our file URL, which is going to go from that result. Then we'll do .output, and then whatever index value we have. So file index, this index ID. Now, remember, this result here is coming directly from replicate, so that's where the output URL should end up being. So what I actually want to check here is basically something along the lines of if that even exists. So I'll go ahead and do a try block here, and then we'll go ahead and do an exception, and then I'll go ahead and raise the HTTP exception. Much like the status 500, it will still be a status of 500, but this time we'll go ahead and do exception as E, and then say server error, and then we'll do something like E in here, right? Okay, so one of the things though is if the output doesn't have that index at all, that's probably going to be another error itself. So let's go ahead and do outputs equals to results.output, and then we'll go ahead and say if outputs is none, we'll go ahead and raise the 404 exception, right? So 404, and we'll go ahead and say prediction output not found. That one makes sense. Then the length of outputs is going to be, of course, grabbing this. So we'll go ahead and do the length of it. So then we just want to make sure that the index ID is less than the length of outputs. Basically, if it's greater than it, then we'll go ahead and say another 404 and say, for instance, that, index or file at index not found. So file at index not found, something along those lines. Because again, this is the index value in a list, so it should exist. Next up, at that point, we now have the file URL. So all we really need back is the content itself. So how do we grab this content is the next big question. And then from there, we're going to go ahead and return something called a streaming response, which we need to import. Let's go ahead and import it from responses. And we are going to return back a streaming response of something. I'll come back to that in just a second. So the content itself needs to come from somewhere. So in here, what we can do is we can create a new helpers file called fetchers, and this is going to import HTTPX, And I'm going to go ahead and do async def, and we'll call this async, or let's go say fetch file async, something like that. And the URL is going to come through here, and it's going to be a string. And then I'll go ahead and do async with http x.async client as client. And then we want to get our response, and this is going to be await client.get of the URL. And then basically if response.status code is not equal to 200, then we want to raise something. In this case, I'm going to go ahead and raise from FastAPI. We want to raise the HTTP exception. So I'll go ahead and import HTTP exception here. And then we'll go ahead and raise that, and I'll just give a status code based off of the response status code that's coming through. There we go. Otherwise, I'm going to go ahead and return back response and response.content. There we go. Okay, so with this in mind, I'm going to go into main.py, and we will now import our fetchers. And we'll use this to grab that content. So content equals to await and fetchers dot fetch file async, and it's going to be the file URL. Now, the reason I'm doing this is so I can have a streaming response, which means that my function, my actual endpoint, needs to be async as well. Everything else should work just fine. This is the one part that I wanted to change. And so that's going to be the final content that's coming through in here. And of course, it will raise an exception if it's not in there. And all we want to do is change this to iterate of some kind. And it's going to be the file content. And then we have a media type in here that we will need to come through, which is going to be based off of the URL and a meme type guess. So I'm going to go ahead and do import our meme types. And let's go ahead and grab that URL again, and we'll go ahead and say our media type and encoding, which we can leave as just an underscore, equals to the meme types.guess type and the file URL. And basically I'll say media type, or we'll just do image JPEG, which I think is going to be our standard one overall. Great. So let's just make sure our server's still running. Sure enough, it is. So let's just break down what's happening here. First off, we still get that prediction detail. This right here is reason enough to not modify that response. That's the reason we did the schemas, or part of the reason we did the schemas in the first place, was so that when we did get this prediction response, we could use it directly from what's coming in from replicate. From there, we're then able to still do the same sort of stuff that we did before. Then, of course, we get our outputs. We look for our specific output, raise an exception if that output's not available. Then, of course, we have that as our URL. That's what those outputs are. Then we grab that URL, and then we stream back that content. So naturally, I still need to test this, but I wanted to build out this URL first before we start doing the testing process. If I need to change anything, I'd go back and forth and make sure that's happening. Now, one of the things about all of these errors is you can definitely combine them and reformat this. The reason I have these errors like this is so you can see exactly what's happening with all of them. Realistically, what I would probably end up doing is something along the lines of having this one, maybe the status code, and then everything else kind of in a try-block exception based off of the file URL itself, not necessarily having all of those things. Like the end user or the end API does not need to know if that file index does not exist. You could just put it in as a page 404 or something else. Nevertheless, we now have this endpoint, so let's go ahead and test it out. Now we're going to see if our streaming endpoint ends up working, where it does the proxy request for us. So what we'll see here is in our notebook, I created a new notebook, which is basically taking everything we've done so far and just changing it only slightly. So if we come through in here and we see the predictions that come through, we can see all of that data. Now, naturally, as we saw before, if there are no files, we don't want to attempt downloading them. So basically, if files is none, then I'll just go ahead and hit continue. Otherwise, we'll go ahead and print out the data that's coming through, which should only be objects or predictions that actually have files available to us. And so of course, if we look in that file list, here we go. So this is great. So now we can actually use those files. We can iterate through those files. So once again, we are going to use the HTTPX lookup just like we did in trigger background. So I'm actually going to go into trigger background and copy that block in there so we can use it all over again. So the idea here is for file, or rather for file path in files, we're going to go ahead and run basically all of the HTTPX stuff. I think I already have it imported up here, so we don't have to worry about that. I also don't need random or session. Now, I definitely could keep those things, but really we are getting detailed views. So the object itself, I can do object ID equals to data.get of that ID, right? So I can use that now as the output, one of the output places that I'll want to use. So in this out path, I'll go ahead and bring that in for that object ID. Now, the reason for this is because then now we can say something like if outPath.exists, then we can just do continue. Now, of course, I still have a few other things to fix in here, but that's a good start. The other thing about the outPath itself is we want to make sure that the parent exists. So I'll do outPath.parent.makeDirs, and we'll go ahead and do exists okay, being true, and then we'll go ahead and say parents equals to true as well. Okay, so the parent directory, of course, is this right here from that file name. We just did it a little bit differently. Okay, so now what do we need to iterate through? Well, we actually are already iterating through all of these files. So realistically, this client here, I can just move it up, and I can now, instead of having files here, I'll throw them here. And this is going to be file path instead of URL. Of course, that means that I need to change a few things, but the reason for that was just to make sure that I'm not thinking it's a full URL, because it's not. The actual full URL is going to take the base URL, which of course is this right here, which I'm now going to rename elsewhere, which I probably should have done a long time ago, but we'll go ahead and do it now as base URL. Now in here, I'll go ahead and bring in base URL, and what do you know, down here, this is going to be the same. So we'll go ahead and use that F string of base URL, and then our file path in here. And there's our URL now. The file name itself is coming from the file path. So I can use pathlib for this one, which would just be pathlib.path of that file path, whatever that ends up being. Now, there's a lot of different ways on how we can think about this itself. We can just use .name. In fact, there's a lot of ways on how we can think about what we want to name this file, because the object ID we could grab as well. But anyway, so now we've got the for loop going through. Let's just check everything. We're going through each file. We're giving it a file name. We're giving it a destination to store it. If that destination already exists, it's not going to even attempt to do it. Then it's going to attempt to store everything. Otherwise, it's going to raise for status. So this right here is an internal URL that we're calling. So that means that we need to bring in our API keys again. So we need to bring in headers that we had before. Otherwise, we'll have some errors. And of course, you could see this by just going up a little bit. That is basically the same thing that's going on, but this is going to persist the request a little bit differently. So now that we've got this, let's go ahead and run it. What I anticipate to happen is a problem. And we see that there is an issue that comes up, parent.makeDirs, and that should not be dirs, it should just be makedir. Here we go, which should generate the directory for each one, and that should be exist okay. The S placement on those is, I guess, counterintuitive for that thought process. Nevertheless, we now have a raise for status here. We've got invalid status code 404 not found for all of that. Now, I actually know what the problem is that maybe wasn't very clear, but it hopefully is now. So if I were to open this up, I am pretty confident that this file exists based off of the API. So the thing that I'm not necessarily confident about is maybe I'm not handling the request correctly. So going back into what we did before, we did almost the whole thing correctly. And that's this right here. So here is our API path. I'm going to copy that and I'm going to jump over into my schemas. And then I'm going to go ahead and take a look at what I end up doing for the schemas themselves. Here it is right here. This is different. So we got files instead of file. Then we also have X, that's the index value, or let's go ahead and change that to IDX. So it's a little bit even clearer that it's the index value, but we also have the suffix on there. Now, a big part of the reason we need that suffix is so that it's stored the correct way, because in some cases it's a JPEG, some cases it's not. So that suffix is important, but the actual in path I have is incorrect. So this is yet another reason to use the Pydantic schema so that we make sure that everything is set up correctly. So I'm actually going to go ahead and change this to files, but one thing I need to do is update my actual endpoint to handle using the suffix. So the important part of this is that we have dot and then the extension or the suffix in here as well as an argument that it will capture. That argument itself doesn't really matter. We actually don't need it. The reason I'm using dot is it's actually not the suffix, but rather the extension in here. And also it's going to separate these things to out. Now, as you remember, I also did talk about doing out dash. This might be a good place for out dash. Now, you also can consider something like this as fname, as in file name, and then doing something along the lines of coming down here and saying index ID equals to fname.split of that ID. That is definitely something you could consider doing as well if you were to change how those file names end up working. But I like using the integer method because it is an index value that we want to grab. So I'm going to stick in with this right here. Great. Simple solutions that we definitely needed to go through. Now that we've got that, let's go ahead and give this another try by running that cell again. And I think at this point, we'll probably end up seeing these images being saved. And sure enough, there they are. So the reason I actually did it this method as well is because I don't need to override or resave the images that are already saved. But now I actually have a whole batch session that can update my locally stored images, which is great. So that if they end up, being deleted or something like that from Replicate, I will have them here. Now in the long run, I would probably want to upload these elsewhere, but for now, as in an object storage like on AWS S3 or Cloudflare's R2, or there's a lot of places to store S3-like technology. The point here, though, is that I can actually grab all of this data, and it's looking pretty good, right? So there's some of these images, which is funny how accurate that looks. But nevertheless, we now have all of it working. We just need to do one major change to our API. That major change comes down to the list predictions results. This right here, not great. It is not great for many reasons, but we just saw a good reason for the detail to change or to be based off of the schema, because one slight little change with the schema made a big difference. Now, of course, another thing we could consider doing is just have other API endpoints that can handle the varying, ways that you might want to do this request in here. That is certainly another possibility where then you would just send it to this prediction output view and it would handle all the same things. In other words, if you were to go to a different extension, let's go ahead and even show you. If you were to do something along these lines, let's say, for instance, you wanted to do out dash and then do the file name here. What you would do then is you would come in and you would use this as a string, and then you would say index ID, and then whatever otherwise is going to be fname dot split on the period, and then you could just return await, and then the other actual function itself with those other arguments in here. If you wanted to support other kinds of endpoints in there for your API, including just simply file. There are probably other ways to improve that. The reason I like this is it's going to be a lot easier to see which API endpoint gets called all the time, and therefore which one you should probably support, even if you do it consciously or not. But of course, how we actually designed the API itself, it makes sense to have the single one that we designed for actually supported. Now we're going to implement schema-first responses. So that means we're going to make some Pydantic models based off of the replicate API requests. So at this point, all we really are responding back with are related to predictions. We actually don't need much more than that at this time, but at some point we might. And in these responses, we might want more data. The last thing I want to have to do is open up this replicate.py module, which is really just a proxy for API requests. Instead, what I would want to do is change the schemas as we've already seen. So the very first one we're going to look at is the generate image schema here. What I'm going to do is I'm going to return back the predictions create and then basically do the same thing for this here. So going into our schemas, then I'm going to copy the prediction detail model, and now I'm going to call this my prediction create model. And what do you know? We're going to do an ID of string, and then we also had a status in here, which was also a string. And hey, what do you know? This one does not have a status in it, so maybe we want to bring that one in there as well. And in which case we would come down in here and we would say status equals to data.get and status, just like that. So with this in mind, I'm going to go ahead and duplicate this from replicate class method, paste it in here, and I'm only going to get the data that I actually want. Part of it might be that URL data again, because, well, if we have an ID, it makes sense that we would have the URL string as well. All of this other stuff I probably don't necessarily need at this time, but I'm going to be well suited to be able to add it back in if I wanted to. So with this in mind, I'm going to go ahead and bring the URL in and the status itself, and that's it. Any other data, I can just go to the detail view, and there we go. Now, naturally, what we want to do also is make sure that we are using the create model as the thing that's responded back with. Great. Simple enough. Now what we want to do, of course, is bring this into main.py, which I should already have the helper schemas imported here. Looks like we do. So the very first one we want to do is the generate one, which is going to have in now our response model. And this is going to be schemas dot prediction create model. What do you know? The actual result itself is no longer just returning that simple result, but rather it's going to be that predict model dot from replicate, grabbing the replicate data, and then we can bring it in as a dictionary. We don't necessarily have to bring it in as a dictionary. I just think that's a good idea, especially with how our schema is set up, as we've discussed before. So I'm going to go ahead and save that. Naturally, I want to test this to make sure it's still working. So going into the app 1 of the proxy generate, adult man dressed up for a pro photo shoot, something like that. Running those two things, there's the schema. Everything's looking good so far. Great. So those two are pretty easy to do. That is the create model and the detail model, because it's really just one dictionary value. And that's also true with the response itself. How do we actually go through the list view itself? So it's a little bit different for the list view, but the concepts are going to be very similar. So going into the replicate module again, I'm now going to get rid of this return statement here. I no longer need it, but now just focusing in on the list view. With the list view, the reason it's going to be a lot different has to do with the fact we did narrow down the results when we saw fit to it. So the first thing is the results in here, well, we just return back simply X, right? It's still a prediction model class, whatever that class ends up being. These things are still valid. The next thing that needs to be valid is this results here. Instead of using a dictionary value, it's going to be dot status, and that's it. Now it's going to have the exact same prediction results coming back as a list of our own. So going back into our schemas, what I want to do is I want to bring that stuff in. So let me just refresh here a little bit. I'm going to copy this value, and then we're going to go forward a little bit more again and bringing in our new schema here. Okay, so these are the items that I wanted to use for my list view. And just these items, maybe a few more. So for the schema itself, it's going to be just like the other ones because it's an individual value. That's typically what you end up doing with list views, is still individual values, basically accounting for this dictionary here. So we've got our ID, our URL, we also have our status, but we had a couple others in there, which again, I can copy from down here as well if I wanted to. And of course, we could also do the started at which one, which is, I believe, an item in there. And we're going to go ahead and do something along those lines. And there we go. So once again, this is now our prediction list model. And this one's going to return back our prediction list. And of course, I just need to get a few other items in here, which we can just grab down here as well. Obviously, we could bring in the model in there too. There we go. And if you start getting this very, very repetitive, then you might want to separate it out to be its own model altogether, or its own function, so that you're not repeating yourself over and over for this from replicate example. Great. So there we go. We now have the list model schema going through. So going back into main.py, what is it that we're going to do? Well, the first thing I need to do is in typing, I need to bring in list here. And then I want to go into the list view itself, which of course we have two of them. I'm just going to really focus in on one of them here, and then we'll copy and paste it. So the first one is just going to be the predictions model here. Those dependencies are still there. They're the same dependencies as they've been. Now I'm going to go ahead and do our response model, and this is going to be a list of the schemas dot prediction model, just like that. Great. So how do we actually do these results then? Well, it's just like what you might expect. It's going to be the schemas prediction model from replicate, and then the result itself. So I'm just going to do x.dict, and then close that off, and then for x in results, and iterating through just like that. Straightforward, but something that I think can be really effective when it comes to using these items. So before I actually bring it into the processing, let's just go ahead and verify that this is working by going into the other model and just seeing that we actually are getting predictions coming back now with that same data coming through. Looks like it is. So we've got created at, started at, completed at. Fantastic. This is a really good sign in terms of the schemas working. And now, of course, the list view has the ID. So anytime we need to change it, we've got the ability to do so right in line in the schema, only the schema, not the actual API requests that we end up doing. So naturally, I want to just verify that this is also working with processing, because I did change how that worked a little bit. So let's go ahead and grab this up here. We'll go ahead and bring this in, which I could probably just copy and paste the other one and just change the status part, but we're going to do it just like this. Then I'm going to go ahead and return those same sort of results here. Save it. Got our response. Everything's looking pretty good. Let's go into our API here now and change this to processing and run that. All I really want here is to not have an error. And let's go ahead and see. We've got nothing processing, so let's go ahead and make something processing by running this. There we go. We've got starting. Starting is also not processing, but at some point it will be, which happens really, really quick. But there's that data coming back so we can see processing. And naturally I can have other status items in there as well, but all of that's working. In other words, the actual, iteration, the for loops that I have going on here is now definitely working. Super cool that this also is just that simple in terms of how we can go forward with this, right? Because now the replicate module itself is just dedicated to getting responses from replicate, and the schemas are responsible for breaking those responses into what we are looking for in terms of the actual API that we're building out. And that's it. Hey, thanks so much for watching. Hopefully you got a lot out of this. I know I did. I had a lot of good laughs seeing myself in AI generated photos. Now, the big challenge here is to take it to the next level, and that is storing those photos somewhere. And I recommend learning how to take everything we did here and store the photos in object storage, like AWS S3 or Cloudflare R2 or the many other object storage options that are out there. Once you can learn how to store them in object storage, then you'll be ready to deploy this application and ideally deploy it in serverless. In a serverless environment, we don't need a database, although we could add one like a SQL database. But what we do have is our Redis cache, thanks to Upstash. It's already prepared for serverless. So it's already well suited to deploy this on serverless. And of course, the reason you use serverless in general is because you don't know how often you're going to end up using this API service at all. Maybe you end up using it a lot, but more than likely, you're not going to use it that much, unless of course you also learn how to support other people and actually build this out for a lot of different users. That would be the ultimate challenge to take this on. Now, of course, if you want to see any of that, please let me know in the chat below. Thanks again for watching. My name's Justin Mitchell, and let's give a thanks to Upstash for sponsoring this one. It is a critical part of this project, but it's also really cool that they help bring it to life. So thanks again to Upstash. And if there's anything that you guys want to see, let me know in the chat below. I definitely want to take a look, and hopefully you get some good laughs out of the images you generate. Thanks again.